Chancellor of the Federal University of Technology, Professor Adenike Timidayo, FAS. Thank you very much. I'd like to recognize Professor Wasi. Welcome. We have an array of professors here. Professor Ellen Olayinka Ogushi, Director ISL and member CSN. You're welcome, ma'am. We also have all the dignitaries would recognize right away. Professor A.F. Ayesomi, member of Futa Government Council, former Dean School of Physical Sciences. You're welcome, sir. We have Professor Adetuyi here this morning. We recognize your presence from chemistry. Professor Ogutimei also step recognized. Professor Okwola would like to recognize you. Professor Eo Adebayo, you're recognized. Dr. Okorie, EMDI, you're recognized. Dr. Miriam Oloye Unimed, you're recognized. Professor Mrs. Aleto, Chemistry, you're recognized, ma'am. Professor B.E.A. Boboye, you're recognized. Biotech Futa. Dr. Ebusike, EMDI. And indeed, all our professors who are seated here, all the members of the Fruta community, greatest Futarians. Are we here? Greatest Futarians? Thank you very much. We'll take, I indulge you, kindly rise everyone as we take the national and the Futa anthems. Thank you. Once again, distinguished ladies and gentlemen, it's my singular honor to welcome you to the first of its kind, the first chapter conference of the Chemical Society of Nigeria, Ondo State Chapter. I was thinking that we would clap because of that. Thank you very much. I welcome you on behalf of the organizers and the LOC of this event. Taking further courtesies, we have here this morning Professor Mojisola Nkiko, Dean Science, Unimed, representing Professor E.I. Adeyeye. Can we put our hands together for one, please? Thank you for being here. We'd like to recognize all the distinguished awardees. We'd like to recognize all the distinguished awardees who are here for the Excellence Award, Professor Kolawole Ajanaku, Professor Nuruddin Abiola Oladoja, Professor Olayide Samuel Lawal. For the Science Advocacy Award, we recognize our distinguished Vice Chancellor Professor Ajanaku, Professor Temi Emmanuel Ologorisha, Professor Ibrahim Abdullahi Safi. And for the Founders Service Excellence Award, we recognize Professor Kolawole Ajanaku. It's a posthumous award. We have a son here. We recognize you, Mr. Universtiy. Can we put our hands together for you? We have Professor Professor Isiaka Adekunle, Professor Aladetimi Augustine Oshubi, Professor Emmanuel Ilesomi Adeyeye, Dr. Kolawole Ajanaku, Professor Olugbenga Solomon Bello. Recognize all of you here this morning. Distinguished ladies and gentlemen, moving on in this opening ceremony, I would like to bring up for his welcome address the Ondo State Chairman, Professor A. Okoronko.
Our Vice Chancellor, Professor Adenike Oladiji, we highly welcome you, man. The National President of the Chemical Society of Nigeria, Professor Rufus Chato, who is ably represented here by the Deputy Vice President, Southwest, Dr. Esther Faboro. Our keynote speaker, who is also the Vice Chancellor of Landmark University, Umaro, Professor Kolawole Ajanaku. Our plenary speakers, Professors Lawal and Oladoja, the Dean School of Physical Sciences, Professor Barnabas Adebola. Distinguished ladies and gentlemen, it is a great honor and privilege to welcome you to the first conference organized by the Ondo Chapter of the Chemical Society of Nigeria. We gather today in the city of Akure, in the Sunshine State, to reflect and synthesize ideas on how to tap into the vast resources available in our nation for the betterment of mankind. The theme of this conference, Innovative Chemistry for National Development, is particularly apt in every respect. In a world of abundance, yet fraught with challenges, our insights, communications, exchange of thoughts and ideas should foster and pave way for innovative solutions to the obvious challenges we face. As chemists, can we begin to recreate nature? Can we manipulate the gifts of the Supreme Creator in such a manner that national development is promoted? I hope we'll find answers to these questions and many others in the course of this meeting. On this note, I would like to welcome the chief host of this conference and the chairman of this session, Professor Adenike Oladiji, our dear Vice Chancellor. I warmly welcome the President of the Chemical Society of Nigeria, Professor Rufus Chato. I welcome in a special way the keynote address speaker, Professor Kolawole Ajanaku, an erudite chemist and Vice Chancellor of Landmark University, Umara. I similarly recognize the plenary speakers, Professor Olawale Samuel Lawal of Chemistry Department, Federal University Oye-Ekiti, and Professor Nuruddin Abiola Oladoja from the Department of Chemical Sciences at Adekunle Adjacent University, Akumba Akoko. I'm indeed very grateful to you all for honoring our invitation as keynote and plenary speakers. I am pleased to recognize the Vice Chancellor of Olusegun University of Science and Technology, Ondo State, Professor Temi Emmanuel Ologorisha, our own product, our Futurian, who is here represented by Professor Ilumobayo Oguntimehi. All our awardees and all our invited guests are respectfully recognized. I also wish to extend my acknowledgements to the esteemed National Executive Council members of the Chemical Society of Nigeria here present, particularly the Deputy Vice President, Southwest, Dr. Esther Faboro. I would like to extend my sincere gratitude to the members of the local organizing committee whose efforts have brought this day to be. I welcome all our participants and encourage you to make the best of this conference. Be active, share your views, ask the needed questions, and forge partnerships that will extend the frontiers of knowledge. To the protocol unit of our university and other members of the media, we are grateful for your coming and for making this event worthwhile. Our students, great Futurians, we appreciate your coming. There is a saying in the chemical parlance, cuddle a chemist and elicit reactions. The opportunity is here for you to explore innovative chemistry. Thank you once again, and welcome to the maiden conference of the Ondo Chapter of the Chemical Society of Nigeria. Thank you, and God bless.
A big round of applause for the Ondo State Chapter, Professor Prof. Thank you very much. Distinguished ladies and gentlemen, making progress, I'd like to bring to the podium now the President of CSN, Professor Rufus Chancellor, who is ably represented by Dr. Esther Fabro, the Deputy Vice President, CSN Southwest, for our address. A round of applause for our address.
The Vice Chancellor, Professor Universtiy, the keynote speaker, Professor Kolawole Ajanaku, the Chairman, Ondo State Chapter, Professor Akambon Victoria, the plenary speaker and other invited guests, Presidential Goodwill Address to the Ondo Chapter Chemical Society of Nigeria on her maiden chapter conference, 19th July to 22nd July 2026. It gives me immense joy and pride to extend my heartfelt goodwill to the Chemical Society of Nigeria Ondo Chapter on the occasion of your maiden chapter conference held at the T.I. Francis Auditorium, Federal University of Technology, Akure, Ondo State. The conference theme, Innovation Chemistry for National Development, is both timely and visionary. It underscores the critical role of chemistry in driving sustainable growth, technological advancement, industrial transformation in our nation. Indeed, innovation in chemistry is the bedrock of breakthroughs in clean energy, health, agriculture, security, sustainable environment, and manufacturing, all of which are vital to Nigeria's progress. I commend the Ondo Chapter for this bold initiative and for creating a platform that will inspire collaboration, knowledge sharing, and the nurturing of early career chemists. This maiden conference is not only a milestone for your chapter, but also a beacon of hope for the entire Chemical Society of Nigeria, as it demonstrates our collective commitment to harnessing the power of chemistry for national development. On behalf of National Council and the entire membership of Chemical Society of Nigeria, I congratulate you on this historic achievement. I urge all participants to engage actively, share ideas freely, live with renewed determination to contribute meaningfully to our nation's growth through chemistry, knowing that it is the central science deriving global sustainable development goals, which Nigeria is also desires. May this maiden conference mark the beginning of great achievements and enduring impact. Once again, congratulations, and accept my best wishes for a successful and memorable conference. Long live Ondo CSN, Ondo Chapter. Long live CSN. Long live Ondo, the Sunshine State. And long live Federal Republic of Nigeria. Professor Rufus Shackle, 16th President, Chemical Society of Nigeria. Thank you.
Thank you very much. I'd like to pause to take a recognition. We have on our list, all the way from Ekiti State University, Ado-Ekiti, Professor S. Olagwe. You're welcome, sir. Thank you very much. Now we'll move on to take the address by the host, the chapter chairman, Professor Victoria Akamba. You're welcome. Can we celebrate our chapter?
Thank you. Good morning. You're welcome. I wish to read my address. The Vice Chancellor, Professor Adenike Tenidayo Olajiji, our Chief Host, the Chairman of the Conference, Professor Isiaka Adekunle Amo, distinguished Vice Chancellors present, Professor Temi Emmanuel Ologun Oyeistep, ably represented by Professor Elemobayo Oguntimehin, Professor Ibrahim Abdullahi Safed from Zamfara State University, graciously represented by Professor Olaide Samuel Lawal, our keynote speaker, Professor Kolawole Ajanaku, the Vice Chancellor, Landmark University. Our plenary speakers, Professor Nuruddin Abiola Oladoja and Professor Olaide Samuel Lawal, national executive members, particularly the President, Chemical Society of Nigeria, Professor Rufus Shackle, ably represented by the Deputy Vice President Southwest, Dr. Esther Oremei Faboro. Council members, Chemical Society of Nigeria, past chairpersons represent deans of schools and faculties, including our own very dean, the Dean of SPS School of Physical Sciences, Professor Femi Barnabas Adebola, the Deans of Sciences UNIMED, Professor Mojisola Olubumi Nkiko, heads of departments, our own head of department, Professor Wasiu Bolaji Tomori, distinguished academicians, invited guests, award recipients, fellows and members of Chemical Society of Nigeria, gentlemen of the press, ladies and gentlemen. My name is Professor Victoria Omolara Enogong Akpamba. I'm deeply honored to serve as your chair for the Ondo State CSN, and on behalf of our entire chapter, I welcome you with joy to this historic occasion, our very first conference. Thank you. Before I proceed, we must pause and give thanks to God Almighty, who orders our steps, who granted us safe journeys here, who makes all things beautiful in this time. We owe everything. Some of you travel long distances, some of you left your families and your laboratories. Some of you prepared tirelessly for this day. For all of it, we say thank you, Lord. To God be the glory. Now look around you. Look at this room this auditorium where we are gathered. Look at the faces of fellow chemists, educators, researchers, and dreamers gathered here today. This is just not another academic event. It is a family reunion of minds, a meeting of the past, present, and the future of chemistry. To our colleagues from various institutions across Ondo State and Ekiti, welcome home. Your presence reminds us that we are not alone in this journey. To our national executive members, thank you for traveling to be with us. Your presence reminds us that we are part of something bigger than ourselves. To our sponsors and partners, we see you, we appreciate you, and we could not have done this without you. Let me share a little story with you. For years, the Ondo State Chapter has been active, really. We attended national conferences. We hosted symposia. We hosted breakfast meetings for the IUPAC. But something was missing. We had a dream, a quiet one, a persistent one, to host our own conference. A conference where the brilliance of Ondo State chemists would shine. A conference where our students, researchers and practitioners can stand tall and say, this is what we can do. That dream felt distant for a long time. There were doubts. There were challenges. There were moments when we wondered if it was too big for us. But we tried anyway. We formed a planning committee. We had countless meetings. We made phone calls. We felt like giving up, but we pressed on. But we believe that if Ondo State could produce brilliant minds, Ondo State could also hold a brilliant conference. And today, right here, right now, we are living that dream. This conference is a proof. It's a proof that our dreams are not just sleeping. It's a proof that we are waking up. It's a proof that we are walking up, and that God is on our side and nothing is impossible. I want to pause and speak from my heart now. When I became the chairman of this chapter, I didn't start from scratch. I stood on a foundation that others had built, brick by brick, year by year, sacrifice upon sacrifice. Today, I want to honor our past chairmen, the visionary leaders who laid that foundation. Professor Kolawole Ajanaku of blessed memory, the pioneer who laid the first stones of this chapter. It was then called Ondo Chapter. Though he's no longer with us, his legacy lives on in everything we do. We miss him and we honor him. Professor Afamefuna Elvis Koronko, who served with dedication and also laid a strong foundation for us who came after him. Then our own Baba, Professor Isiaka Adekunle Amo, my leader predecessor, a mentor, a guide, and now the chairman of this conference. Please help me celebrate him. He really put in everything. It's like a David to my own Solomon. If you understand the Bible story, you will know what that means. When I needed advice, he was there. When I needed encouragement, he gave it. His willingness to continue serving, even after his tenure, speaks volumes about his dedication to the Chemical Society of Nigeria. To these three men, and to everyone who has served in this chapter before me, thank you. Thank you for your labor was not in vain. Your sacrifices are not forgotten. This maiden conference stands as a monument to your dedication. We are standing on your shoulders, and we are profoundly grateful. Our theme for this conference is innovative chemistry for national development. It sounds very official, doesn't it? But let me tell you what it really means to me. It means that the work we do in our laboratories is not just for grades or publications. It is for people. It is for the mother in the village who cannot afford imported medicine, but could afford something we can produce locally. It is for the farmer whose crop fails and wastes, but could not be turned into wealth. It is for the child who drinks contaminated water, but could drink clean water if we apply our chemistry. Nigeria is hurting. We import what we could make. We waste what we could use. We pollute what we could protect. The solutions are not somewhere out there. They are not there. They are here. In our minds, in our hearts, in our laboratories. Chemistry is not a cold science. It is a science of transformation. It takes raw things and turns them into useful things. It takes problems and turns them into solutions. It takes hope and turns it into reality. That is why we are here. Not just to talk, but to transform. I want to be honest with you today. We need more than just good scientists. We need good people. Please be kind to one another. This conference is about networking. But more than that, it is about building genuine relationships. When we were visiting the Vice Chancellor this morning, she mentioned to us that the VC of Bowen University, they met in a conference like this. Professor Babalola, they had met in the conference like this before they met as Vice Chancellors of universities. So please, network. The person sitting next to you could become your collaborator, your mentor, or your friend. Treat them well. Our speakers are prepared deeply. Listen with open mind. They are going to share their best with us. Let us honor them. Let us listen, not just with our ears, but with our hearts. Science grows when we share. Do not hold all your ideas. Let them fly. Let them grow. Let them help someone else. Do not live here the same person you arrived with us. Take one idea, one connection, one new perspective, and use it. This is our first conference. It will not be perfect. There will be hiccups, challenges here and there. But what matters is that we started after all. And starting in the hardest part, isn't it? We have already won. And speaking of excellence, I am proud to announce that we recently partnered with the Ondo State Commissioner for Education towards a chemistry quiz competition for secondary schools across the state. The results have been announced, and we will have the award taking place in this conference. To the Commissioner, we say thank you for your support. To the teachers that came on Saturday with their students, we appreciate your dedication. To the students, we celebrate you. You are the future of chemistry in Nigeria. I am glad to announce our award recipients to you. Individuals who have contributed significantly to chemistry and to our nation. We have the award category Science Advocacy Award. We will be conferring it on Professor Adenike Temidayo Oladiji. Is she not wanting to please let me celebrate. Professor Zeni Emmanuel Ogorisha, Professor Ibrahim Abdullahi Safe, those are in the category of the Science Advocacy Award. Then we have the Founders Service Excellence Award. Professor Kolawole Ajanaku, this one will be done posthumously. His direction is here. Thank you for coming. Professor Afamefuna Elvis Okoronkwa, Professor Isiaka Adekuyamo. The Lifetime Service Award will be conferred on Professor Alade Somi Augustine Oshodi, Professor Emmanuel Ilesomi Adeyeye. Then we have the Meritorious Service Award that will be taken by Dr. Wahab Bola Ayoade, also posthumous. He was a gentleman that really worked for the success and growth of this chapter. We miss him. So it's going to be a posthumous award. The Valorization Award will be taken by Professor Lubenga Solomon Bello, Then the Excellence Award that we shall be conferring on our keynote speaker, Professor Kolawole Ajanaku, Professor Nuruddin Abiola Oladoja, the plenary speaker, Professor Maiden Samuel Lawal, another plenary speaker. To all our recipients, these awards are not just pieces of material. They are expressions of gratitude. They are symbols of how much we appreciate what you have done for us. God bless you all. I cannot end without saying thank you to Professor Ajanaku, our chief host. You opened your doors to us. You believed in us. You gave us a home for this conference. We are deeply grateful. We also appreciate you, Ma, for the CDT testing facility that you provided pro bono. We are grateful. To Professor Isiaka Amo, our conference chairman, your willingness to continue serving even after your tenure, it speaks volume of your dedication to us. Thank you, sir. God bless you, sir. To Professor Kolawole Ajanaku, our keynote speaker, you did not have to come. We were busy. We were visiting our busy footer, and he said a lot of times you were invited here, but you couldn't come. But you still made out of that busy schedule. You came. Thank you very much, sir. We appreciate you. Thank you for honoring us. To other professors, we appreciate you. Our own Professor Wasiu Bolaji Tomori, thank you. Thank you very much for your patience, for your donation, for your support, for everything, for believing in us. We are grateful. As we close, I want to speak to you from my heart. This conference is not just about chemistry, it's about people. It's about a better Nigeria. We may not solve all the problems today. We can't solve it in these 2 days of this conference. But we can plant seeds. We can inspire young minds. We can build bridges, networking. We can show the world that Nigerian chemists are brilliant, passionate, and ready to serve. When you leave here today, I want you to remember 3 things if you forget everything. Remember that you matter. Your work matters. Your idea matters. You can tell anyone, anywhere, that is trying to challenge you, just tell them that you what? You matter. Can we chorus it? Yeah, you matter. You are not alone. You are in a community of chemists standing with you and cheering you on. We are ready to help you. You can make a difference. Start small. Start now. Start where you are. The difference will come. Let us remember our theme. Innovative chemistry for what? National development. Let us take it home with us. Let us live. Let us make it real. My dear friends, I've come to the part where I must step aside. Because although I am the honor of serving as chairman, I'm not the chief host of this conference. That honor belongs to someone else. It's my privilege to be handing over to our chief host, the Vice Chancellor of FUTA, Professor Universtiy, to formally declare this conference open. Please join me in welcoming the Vice Chancellor to the program. Thank you, everyone. God bless you all. May this conference be everything we hope for. Amen.
Thank you very much. May we please be seated? Thank you, Madam Chairman, Ondo State Chapter. The Vice Chancellor, Landmark University, Professor Kolawole Ajanaku, the representative of the Vice Chancellor of Ondo State, our brother Professor Olumoisha, the chairman of this occasion, Professor Amo, I call him our father. Top government functionaries here present, minors, spiritual and temporal, other speakers at this event. I have Professor O.S. Lawa and Professor Oladoja, the Dean School of Physical Sciences, Professor Femi Barnabas Adebola, other deans and directors,
here present, Chairman, Chemical Society of Nigeria, Ondo State Chapter, Prof. Victoria Omalara Apamba. She taught me how to pronounce her name this morning. The Chairman, Local Organizing Committee, Prof. Elvis Okoronko. Fellows of the Chemical Society of Nigeria, eminent scholars from all over the southwest and even Nigeria. I can see Professor Upola here. Thank you for joining us. I must recognize especially the representative of the president of CSN, that's the vice president of the Southwest, isn't it? Thank you very much, Ma. Professor Fabor. Eminent chemists and scholars, distinguished participants. I recognize especially the wife of our chairman, Mrs. Amo. She's also our mama. When the husband is our papa, the wife has to be our mama. Gentlemen of the press, great Putarians, I recognize you all, ladies and gentlemen. It is with great pleasure and profound sense of purpose and responsibility that I welcome you all to the Federal University of Technology, Akure, for the maiden edition of the conference and award presentation proudly hosted by the Chemical Society of Nigeria, Ondo Chapter. For us who say, welcome to FUTA, we are the best university of technology in Nigeria. I hope Ondo State is not jealous, but the truth is, data don't lie, statistics don't lie. We are scientists here. FUTA was just crowned the AI University of the Year. We are the second best STEM university in Nigeria. And as we speak, we have a research portfolio. For this year alone, our grant is over 1 billion naira. So when we speak with facts, and we speak to what we know. Of late, FUTA has become a destination of choice for conferences, and we are happy. In the last 2 weeks, we hosted like 5 conferences. I think there's the 5th one. We started with the School of Computing, with the Nigerian Society of Biochemistry and Molecular Biology, the School of Computing. We had the Green Microbiology Conference. We had the Research Conference and Seminar of the Central Research Laboratories. And here we are today with the Chemical Society of Nigeria. Tomorrow we'll be hosting the School of Life Sciences Conference also, and so on and so on. So we are happy that we have become a destination of choice. This is one of our responsibilities as the university. I must say that I'm always fascinated by firsts in any positive endeavor, because it is not easy to be a pathfinder. People can sit down and discuss endlessly, but like it is said, talk is cheap. It takes a lot of courage and sacrifice to be first. That is why it is often said that beginning is half the battle. The first would forever be first. So I congratulate the people behind this great initiative. As they are celebrating their first, FUTA is also sharing in the glory, because as it is now, FUTA is hosting the first maiden, the first conference of the Chemical Society of Nigeria, Ondo State Chapter. Wherever the mystery is going to go, FUTA will go with it. Thank you for giving us the privilege and the opportunity to share in this history. Today we gather not just to discuss the marvels of science, but to champion a critical catalyst for our future, captured perfectly in this year's theme, innovative chemistry for national development. We are here to entrench the centrality of scientific innovations to our national development, and I'm very glad to be a part of this historic event. I must pause at this point to express my profound gratitude to the organizers of this conference for conferring upon me the Award of Science Advocacy. To be recognized at this maiden edition is a privilege I do not take lightly. I accept the award not as an end point, but as a call to continuous service. Like the character boxer in George Orwell's classic Animal Farm, I will work harder. In an era where our world faces unprecedented complex global challenges and is defined by rapid technological advancements, science is our most reliable compass. Chemistry is often called the central science because of its bridge position between life, physical, and applied sciences. For me as a biochemist, I say we are part of the offshoot of chemistry. And as I said this morning, if as a biochemist I enter the biochemistry class to beginners, the easiest way for me to define biochemistry is to simply say that it is the chemistry of biology, or the chemical reactions taking place in biological systems. So, there is no other way to define biochemistry without chemistry. So we believe that we are offshoots of chemistry. From the development of life-saving pharmaceuticals and sustainable agricultural inputs to clean energy solutions and advanced manufacturing materials, chemistry drives modern civilization. However, raw scientific discovery is no longer enough. To achieve true national development, we must merge scientific innovations with persistent, passionate, and convincing science advocacy. The most powerful tool in that regard is our ability to communicate clearly and passionately. We must ensure that the groundbreaking solutions engineered in our laboratories find their ways into national policies, industrial supply chains, and the needs of everyday people as well as elites. Technological advancement directly enhances a nation's economic resilience, ensures food security, and improves the overall quality of life. Furthermore, integrating chemical research into strategic national framework is essential for achieving long-term sustainability and industrial growth. Sustained investment in chemical and chemistry education and academic research therefore enables nations to reduce their reliance on expensive imports and build an independent, knowledge-based economy. Science advocacy is the bridge that connects the brilliance of our researchers with the everyday realities of our society. I welcome with utmost regard the keynote speaker, a colleague and friend, Prof. Kolawole Ajanaku, the Vice Chancellor, Landmark University, Kwara State, the plenary speakers, Professor O.S. Lawal from Federal University, Ekiti, and Professor Eni Oladoja from Adekunle Ajasin University, Akungba. At this point, I wish to also congratulate the winners of the chemistry quiz competition for Ondo State. I thank the Chemical Society for organizing this. In these winners, we see promise and we see innovators of tomorrow. And I urge the society to continue to support the advancement of chemistry education at the lower levels. I thank the chapter chairman, Professor Victoria Omalaya Akampan, for creating yet another opportunity to put footer in the spotlight and an avenue for our scientists to interact and network. For us as a university, the staff in chemistry department has continued to contribute significantly to the progress of our university. They are not only pure academic, they are integral part of the administration and management of the university. For example, our International Scholars Lodge is manned by a chemist is manned by a woman chemist. How do you say that? A woman chemist, Professor Mrs. Helen Ogunṣuyi. Professor Ayesami also is a member of the Governing Council of the University. So when I see him, I have to respect him as my employer. He was the dean of the old School of Science and then the dean of the School of Physical Sciences. He was chairman committee of deans. He is a great man, a great leader. And our Baba, Professor Amao, is just our father. He's been the chairman of the primary school management board for years, and he's also the chairman of the Futa Muslim community, ensuring peace within our university. I can go on and on, just to let us know that our chemists are not just academic chemists. They are integral part of our university. And I find this maiden conference, I want all participants to engage in robust, solution-driven discussions. Let us use this platform to forge new partnerships, collaborations, advocate for increased investment in research and development, and chart a progressive course for scientific advancement in our country. Let us inspire the next generation of innovators. I've often said that my generation didn't meet Nigeria like this. And I'm sure many of you older people will agree, we did not meet this Nigeria that we have now. And I believe it is our responsibility to hand over a better Nigeria to the generations to come. Whatever Nigeria is today, the universities, we cannot completely absolve ourselves from whatever.
We're not going anywhere. We're going to start the next session, but we'd like the members of the eye table to take some photographs for the records. Please have a seat, distinguished ladies and gentlemen.
Good morning, everyone. We wish to confer the award of science advocacy upon our vice.
So, and on this occasion, on the first, which is the maiden CSN conference of Ondo State Chapter, I am privileged to give this award, which is called the Award of Chemical Science of Nigeria, the Science Advocacy Award. I'm not saying you. We are not giving this award out of contest. She is a chemist. Alex is a Professor Ajanaku for all the things you do in Federal University of Technology Akure. We appreciate you today, 20th July 2026. Please keep the flag flying. Please, are we happy?
Can we celebrate the Vice Chancellor of the auditorium? Thank you very much. Welcome back, distinguished ladies and gentlemen, to this session. And we want to start by taking a goodwill message by the Dean School of Physical Sciences, Professor Barnabas Abibola. You're welcome, sir. Can we put our hands together for you, Professor?
Good morning, ladies and gentlemen. All protocol duly observed. On behalf of the School of Physical Sciences, FUTA, I want to congratulate the Chemical Society of Nigeria, Ondo State Chapter, and more importantly, the Chemistry Department of FUTA on this first conference being held in FUTA here. And at the same time, I want to congratulate Federal University of Technology Akure for hosting this particular conference. It will have taken place at that place, but since taking place in our school here, and then we are holding it for the first time, I want to congratulate the chapter, I want to congratulate the chapter chairman, the person of Professor Apangban, and all the chemists that are in the house. I want to ask a question, and that's where I will stop. The question is, what is not chemistry? So, if everything is chemistry, I also am also a chemist. Congratulations.
Thank you very much, Professor Adebola. Can we put our hands together for him once again, please? Thank you so much, distinguished ladies and gentlemen. We would like to move on to the core of the event, which is we will take the keynote address by our distinguished Professor Kolawole Ajanaku, Vice Chancellor, Landmark University, Ondo, Kwara State. We'd like you to come to the podium, sir. And I am privileged to read a citation before it takes his address. It's a keynote. Professor Kolawole Ajanaku, please come here, sir. Can we celebrate him as he comes, please? Professor Kolawole Ajanaku is a distinguished industrial chemist, material scientist, and university administrator whose career exemplifies excellence in scholarship, research leadership, and institutional development. He obtained his BSc, MSc, and PhD in industrial chemistry from the University of Ibadan, demonstrating an exceptional commitment to academic specialization. In 2011, he completed a prestigious SIR postdoctoral fellowship at the Central Glass and Ceramics Research Institute under Professor S.K. Das, advancing his expertise in ceramic matrix composites and advanced materials. Professor Ajanaku began his academic career as a graduate assistant at Ladoke Akintola University of Technology in 1995 before joining Covenant University as Lecturer 1 in 2007. In 2015, he became the first professor of industrial chemistry at Covenant University. He served 3 consecutive terms as head of the Department of Chemistry, 2011 to 2015, later as Dean, 2017 to 2019, and subsequently as Director of the Covenant University Center for Research, Innovation, and Discovery. Since September 2023, he has served as the 6th substantive Vice Chancellor of Landmark University, Ondo, Kwara State, Nigeria. His leadership has strengthened research, innovation, and university-industry partnerships, including pioneering waste-to-wealth initiatives and expanding international collaborations. He has served extensively as an external examiner, professorial assessor, and postgraduate supervisor across Nigeria and outside Nigeria. Professor Ajanaku has received numerous honors, including Outstanding and Exceptional Lecturer Awards, the Covenant University Chancellor's Award, the TWASC SIR Postdoctoral Fellowship, Professional Fellowship of the Chemical Society of Nigeria, the 2024 Nigeria Academic Excellence Award as Vice Chancellor of the Year, Private Universities. I believe we can do better than that. Thank you very much. His research spans materials chemistry, ceramic matrix composites, nanotechnology, corrosion prevention, food chemistry, as well as waste and energy materials management, with more than 2,370 Google Scholar citations. Thank you very much. And over 1,100 Scopus citations, age index 17. He remains an internationally recognized scholar, visionary academic leader, and accomplished material chemist. Distinguished ladies and gentlemen, I present to you this morning Professor Kolawole Ajanaku, Vice Chancellor, Landmark University of Ibadan, for his keynote address.
Thank you very much.
achievement is by grace. It is for those that are given the privilege to achieve. I want to recognize the Vice Chancellor of Federal University of Technology, Akure, who has just performed our own assignment. And on behalf of the Chancellor of Universtiy, I also bring greetings from University. That's Dr. David Oyedepo. Please permit me to stand on the existing protocol. And once I'm standing on the existing protocol, I must not but recognize Professor Amo, who is in the house. He's a relevant statement in chemistry. Professor Amo assessed my professorial paper 20 years ago. And what a coincidence, there are two assessors. The second assessor, who was also a professor 2011, before I became a professor 2015, was also in the house. Professor Lawal. So seeing them this morning, I just said, I hope I'm not going for another assessment. Baba, thank you, sir, for the privilege. Thank you, Professor Lawal. Let's just go straight to the point, and at the end of the day, we will look at ourselves and know where we should go and what we have been doing that we have not been doing right. It's a privilege to give this keynote address. Professor Molara, thank you for calling me for this assignment. We call it keynote. There are some things to note in the keynote. That's why it's called keynote address. And now I'm not addressing novice. I'm addressing professors. I'm addressing elites. I'm addressing people that knows the job, even more than me. When we talk about green chemistry, my biology is there and environmental. Professor Mawa is also there. They know more than me. And of course, during the plenary session, we will hear more. It's a great privilege to stand before us to speak on innovative chemistry for national development. The first thing that comes to mind is what is innovation. What have we been doing before that we are not doing right? What are the things that we need to now do again to ensure that we get to the right track? I can see it as a process of creating. Come up with an idea. I see it as a process of improving. I see it as a process of bringing products, as it was said by the Vice Chancellor Futa. Or you improve on our services in order to bring value to our process, or to solve problems that is facing us as a country. And we are not doing it in such way that is nowhere different from the path in which others have been following before. I see it as thinking differently, challenging the status quo. Don't say it has to be like this. No, we have to stand up and challenge. It has to be like this. It's not written in stones. Even if it is written in stones, ceramic composite and nanotechnology will change the format of the stone to read another thing. It is finding better solutions to existing or emerging challenges. It is about creativity. And I want to say that the new generation that we are in, the Gen Z, very creative. Very, very creative. And I enjoyed my students very well, especially when they are doing their postgraduate with me. give them the topic. They come up with creative ideas. And I don't kill those ideas. I only encourage those ideas and then look for opportunities for them so that they're able to implement that idea. Oh, I have a friend in Europe, I have a friend in Germany, can you go there? But when you get there, not your humanity worship. Don't spoil the legacy that I have with them. Do your work neatly, come back with good reputation, and then you fly. I want to say today that the majority of them, if I can count, I can only count only one. Yes, that reminds me, sir. Also, my wife, you trained Olapisi at Demosu, first degree. Ademosu went to me for masters. I trained her for masters. I trained her for PhD. Collaborative work. Laying a good foundation. Olabisi is doing well today, sir. I think I need to call her. I just met her now. She's the only one remaining in Nigeria. All other, my 10 students, they are abroad. I'm not saying mobility. Not that I'm not saying brain drain. But why are they going abroad? We have a problem with our system in the nation. If our system in the country is just like what they are looking for there, they will not go. In fact, our American president is already building a rule. Once you finish your program, go back home. Within 3 months. I must not see why. He wanted them to come back home so that they can impact. Innovation means, from the word, innovate. And when you look at the word innovate, you see IoT, Internet of Things. And that is why I said AI is also part of the innovation. There are forms of innovation. We have product innovation, in which we bring out product. So, today, sir, that girl has so many products, from food chemistry. She has so many products from food chemistry. Not the products that is not just, the products are branded and has the necessary requirements to meet up and compete in the global world. Recently, we just won a grant together under the Chancellor's grant to bring out products to heal cancer from the lifting tea, producing the lifting tea for cancerous people. It was an initiative from her, and I encouraged her, and she applied. And now she's enjoying that grant, and we are doing the work together. We are expecting another one. Process innovation. We have been doing a process before. Let's see the way we can do something about it so that it can be much better. In administrative, I know the VC also understand this, VC Futa also understand this. Let's innovate our processes. Instead of having too much papers on our table, let's do e-governance. Everything comes in with treats. A few weeks ago, I was away in the country. But that didn't stop my work. Everything digitalized. Sent to my mail, sent to my WhatsApp. I will attend to it there. Sign it on my card, send it back to the country. Action goes on. That is innovation. Business model innovation. Don't let us use the format of opening so many shops under one building and all of them are selling the same thing. Coca-Cola, biscuit, ice cream. Whereas some people are inside their house and they are doing digital business innovation, social innovation. This is deep, but I know the Gen Z will like it. For social issue, if I want to do wedding, I don't need to bother my head. I only need to spend my money for my kids. I want to do wedding for my kids. Somebody will just take up the entire thing, event planner, they call themselves. And it will be properly and well delivered. Once they have, and they have checked their reputation. It also helps us in terms of digital education, in terms of social innovation. Students can do assignments right in their room. It helps digital education very well. Professor Mola, thank you for giving us this 8 thematic and 1 argument. The thematics given, they are 8 in number, and the argument is innovative chemistry. Number 1, advanced materials and nanotechnology. We have gotten to an era in which we need to change the format. What have we been doing in Nigeria, and where are we, and what are the lapses remaining for us to move forward? Number 2, wastewater chemistry and remediation. Recently, when you check social media, you will see flood in Lagos. Let me tell us, we are just starting. I know Professor Prof will talk about environmental. We are the one disturbing the environment. We are the one that is causing the issue. But what can we do? Number 3, industrial materials, chemistry. Number 4, food development chemistry. Gone are those days that we eat the same soup. It is my mother's soup. Okay, yeah, I'm One day, the mother will die and go beyond. If she did not pass that recipe down, you will get your wife's soup. It becomes your wife's soup. And that is okay. I don't want to say it. So a mother or a wife that doesn't go to the mother to learn the recipe in which the husband has been eating, to have it to her own recipe, that is part of food development. I remember when I got married, my wife would always be in the kitchen with my mom whenever she comes around, learning the recipe in which she has been feeding me with, and now she's gone beyond. So she learned her own mother, and from my own mother, combined it. Before I got married, I was thin. After marriage, I began to grow fat. And that means combination, reaction of A plus B, giving us C and D. And then medicinal chemistry and drug discovery. What are we doing about it? The twins are there. I know my boss, they will talk more about that. We have been taking I go. That's green chemistry. Then how do we combine this green chemistry to drug that is synthesized, so that at least we can use that to heal every disease like we have, in which my student combine food chemistry with medicinal in order to treat cancer. There's a kind in modern chemistry. There's bioremediation, and there's also the biodegradable packaging. I know just now we have been served with PET bottles, water in PET bottles. It's good. We are under a shade, but we don't know where that PET bottle is coming from. Maybe it has been put inside the sun over time. I'm not scaring you. But we will look at it pure, clean. So, without much ado, let's go into the business. There are 8 different chemistries. I call it chemistries because we are given the thematic. That's chemistry in industry. That's why I decided to call it chemistries. But we have one same discipline. The nation that matter, all 8 will not need to import their future. They will need to manufacture it. All those 8 thematic, you don't need to import from anywhere, but you can do it right from where you are. Let's look at the first one. Okay, before we look, let me lay this foundation. Chemistry sits beneath every sector of development. Thank you, Dean. You also mentioned it. The Dean of the college also mentioned it. That what on heart is not chemistry. Every development, is it clean water, affordable housing? The VC just mentioned that. In fact, when I came in, what I looked at was that place first. And then I saw a ladder here. I said, what's this ladder doing? Food security, medicine that is accessible to all, industrial output, environment that is livable, that whenever rain is falling, you are not scared. Everything resolved at some point, and into a specific chemical operation or chemical reaction that must be done. A bond must be broken. Another one must be formed to form a molecule. And the molecule must be purified. And the material must be synthesized. And then if you want to bring the bow into the unit, you put a microbes inside to kill it. That's what I'm looking at. We put a microbe there, we kill the microbes, we first of all culture, know what is in there, and then kill the microbes, and then we use a thin layer paint or to pour after screening. I'm just suggesting, but we have the researchers in the house. It is good to point out that Nigeria imports refined fuel, but thank God for Dangote. If we did not start the refinery, we will be buying fuel now 2005 minimum. Even when it started, they don't want him to succeed. Active pharmaceutical index, API, ceramic tax, we still import. Ask the Igbo boys. People know they will tell you that they do it from Abba, but the thing is coming from China. Specialty packaging. And then we have kaolin, plenty in Nigeria. We have Vespa. We have crude oil. We even have cassava. And then we have the Gen Z. Many of them are going for courses now. I told you this year, I said, we need to sell our chemistry. Substitution is getting reduced day by day because the students are going for AI, compute. If you don't go for computer, you go for telecommunication, you go for this, you go for artificial intelligence. What's happening to chemistry? Let's make it industrial. Let's make it work. Let's sell it. So I look at thematic 1 fast, so that we can gain our time. Engineering matter at the nanoscale. It's talking about advanced materials and nanotechnology. there are two processes. Of course, when we talk about nanoscale, we are talking in terms of ranges between 1 to 100 or beyond, nanometer range. Very, very tiny, it cannot be seen, but we can reach it via engineering advanced material. The only problem they have is just that it has to be synthesized through eco-friendly, low toxicity routes, because the major one that we know is just synthesizing through chemical synthesis, and those ones also has toxic effect on the environment. We can either go by top-down synthesis, that is, we break down a major compound to know the lowest molecule involved, and then pick it up from there, and then re-engineering it back to the product in a much less toxic way. We can also have bottom-up synthesis. That is, we take it from the grassroots and then build it up. In fact, I always love the bottom-up. Once we have a waste, or once we have let me just call it a waste. What I always do is to characterize that waste. What does it contain? Oh, I can see calcium there, I can see potassium, I can see this. What I do is also bring in my chemistry. And then let's see the way we can build up something from there. And then we'll build it up. And it can cut across agriculture, cut across energy, cut across construction. In fact, the best way for nanotechnology is in construction. Electronics, and also in healthcare. There are quite a number of reactions that can take place, and then characterization method that we can use. Those things may not be available in the country. That is where our government has failed us. We have come with so many policies. We have come with so many communiques after conferences. But when it gets to them, they push it aside. But I think the narrative is changing gradually. Once we have, at least, Commissioner for Science is is a friend of the university, and he has also helped in ensuring the chemistry competition to be a success. So the narratives are changing for us to have the best. Let's take a look at the case study. Grain synthesized magnetic nanocomposite. This is a Nigerian paper. And when we look at that chart, Malaysia, in terms of national nanotechnology advancement, Malaysia is standing tall. Nigeria is the fourth in nanotechnology publication. And I believe many of us are champions in this area, especially the professorites that are here. We are doing well. 71 Nigerian institutions are active in nanotechnology, collaborating with almost 58 countries. Yet, only 6.5% of that research is locally funded. Only 6.5%. Majority of it is outside. On the composite national R&D index, Nigeria scores 38 against Egypt 59. We are fourth in Nigeria, we are fourth globally. But of course, if your son comes home and he says he's fourth position in the class, you say, try him next time, you shake his hand. But when he now tells you that he scored 38 over 100, you, as a lecturer, I know that 38 is not a pass mark. We still have a long way. We still have a long way. Major issue. Major issue. We need to be funded so that we can have products manufactured in our country. God will help us. I move to thematic 2, wastewater chemistry and remediation. Reclaiming what industry discharges. At the end of this lecture, or at the end of this address, I'm going to say that the industry, we should collaborate with them. But I know that there are many industries that doesn't want some fact in their industry to go out. I was called. I brought in a collaboration MOU for my university, and then by the time we visited them, I was called to come and look at some of the wastewater treatment plant. What I saw, I cannot say. I cannot say because I said these are some of the things that are being discharged into the waste streams. And then at the end of the day, we are having so many diseases around. Whereas all these things can be done holistically as is obtainable abroad. Effluents should be screened. Process of precipitation should be done so that you can absorb them or adsorb them, whatever, via Ondo State program, and then before you discharge. But to be candid, most of the time these are not followed. Of course, we know the absorption principle. The major one is NAMA and the fragrance. But it's interesting to know that there was a review conducted in Nigerian micro waste absorbent, in which we can use coconut shell. I hope Professor Bello will be here. He's a genius in that area. So I decided to choose this area. Coconut shell, rice husk, cassava peel, and that can do up to 78 to 98 removal of all these heavy metals. The case study in an hospital sewage sludge in Ibadan was also looked into. And this is a recent paper. You can say, it's happening in Ibadan. Yes. If it's happening in Ibadan, it can happen anywhere. It can happen in Akure. It can happen in Omuaran. The only thing is just for us to be able to also situate our own. At UCH Ibadan, cassava peel extract fermented with Aspergillus niger were used as a power leaching agent for every metal removal from sewage sludge. And when it was tested, pH 3 to 5, and within 1 to 12 days of contact time, and this was achieved. These are areas in which we can also go into before we now discharge. Thematic 3, industrial material chemistry. From local minerals to manufactured goods. From local to products. And your product, if it is very good, it goes into global. I was privileged to use silica sand, soda ash, and feldspar when I went for my postdoc. And I came out with tiles. What amazed me was that when I was going, I went with our local raw materials in Nigeria. I went to get the kaolin, Montro Mominonat. And I got to CGCI in Kolkata, carried out the experiment. The program was supposed to take a year. But within 3 months, I finished it. And I told my husband, I said, I'm going back home. He said, for what? I said, I want to go and clear plastic waste. He looked at me. He said, now compare your local kaolin or your clay, Motomolino of Nigeria, compare it with the one we have in China. Compare the two, and then let's see the difference. Within 1 month, I finished it. He looked at me and said, this man, you want to kill yourself here. So I came back home, collected samples of polymers, nylons. Did the same thing, went back. Also do the same thing. Why? Looking for products. And he was amazed with the product that we had. One of the things that they enjoy most there is that the industry will bring the fund to the research institute. And then our industries, we are not doing that. The industry will bring a fund to the research institute, solve this problem for us. And that's the way to go. Quite a number of things that we have in Nigeria. First part is available. Kaolin is available in abundance, consisting of silica. Bentonite is there. Limestone, God has blessed us with this. And from this, combination of this can give us glass with different thickness. But when we talk about the glass industry in Nigeria, we always think of this glass industry in Ibadan. Where is it today? Now, a case study of that is in the refractory grade clay of Umuoke in Nigeria. Umuoke is in Abia State. This is a recent paper, 2024. And they have the classification silica 56.41. Silica, that's silicon oxide in that material. With high silica and alumina content, typical of aluminosilicate clay, corresponding strength of 15 newtons per mm, very strong. Even though the porosity is 21, but we can enhance the porosity by increasing the amount of alumina and then subjecting it to higher temperature. If it's refractories is 1680. When you now say now, how can we achieve that? It's achievable. It's doable. And once we achieve that, the strength will increase from 15 newtons per mm square. And the porosity will be less than 5. And then we'll have fine tiles, polished. This is doable. I did it. One of my PhD students also did that. And then he's in Europe presently. After he finished, he went to South Africa. From South Africa, he moved to Europe. Why should they be enjoying it? Enjoying him while we need him in the country. Thematic 4, food development chemistry. I won't go too much into this. Of course, I'll give an example in which one of our students, Musalawa, has done a great work on her. And she's having so many products. From beta-carotene to enzymatic cleavage to vitamin A. What she was looking for is just a beta-carotene. Is it present in carrot? Yes, it's present. Mix it with this. Mix it with, okay, tomato. We also have beta-carotene. Mix it with tomato. Blah, blah, blah. And then, somebody might be wondering. In fact, when the problem came, she was saying, how do I dry tomato? I said, you are not going to biochemistry lab. You go to biochemistry lab. You will know how you dry tomato. In fact, with the latest branch, you already have a dryer. Blend the tomato now, and then within the next 48 hours, the tomato is dried. Then mix it up, do some internal checks, and then go ahead to package it, and then do all the necessary tests, including the cancer test, and it passed it. Thank you so much. So, even yellow cassava, we have cassava plenty. Yellow cassava in Ondo State here. What happened? A randomized controlled trial. This has even passed publication stage. It's in trial stage. And it has been published in the American Journal of Clinical Nutrition. They tested it against 176 children, aged between 3 to 5. They tried yellow cassava, and then they tried the white cassava. And they were giving them the meal of this food twice daily, 6 days a week, for 93 days. Somebody will say, hey, one short call. But we know, after the discovery, that Nigeria produces 55 to 56 million tons of cassava a year, and the world's largest output, with over 1.5 million farmers already growing vitamin A varieties. And that vitamin A is helping. The white cassava is giving 74%, while the yellow cassava is accorded 221. What a jump. I don't know why. Whenever they want to prepare a bar for me, I said, please, definitely, I don't want this white. I'm not condemning their religion. But just give me this yellow cassava. Yellow garlic. When you put the okele like this, it's very, very soft to move. When it goes to your esophagus, it slims down. So, maybe that's one of the reasons why the Igbos are always stronger than the Universtiy with our white garlic, the food for thought. Medicinal chemistry and drug discovery, from native flora to evidence-based medicine. Get the leaves, prepare the leaves, go through bioassay-guided separation or fractionation. Somebody was asking, how do you know about organic so much? I said, my spouse is also a chemist. My wife is also a chemist, and organic chemist would be called natural products. So when she was doing her PhD, I always used to laugh. I can't leave her there, sir. And then I sit down at home. I said, I'm a professor. Today, she's also gathering her paper to become AP, associate professor. That's when I got to know about organic chemistry, natural products. The sequence, the isolation process, the characterization. Very interesting. That is when I now know, because she worked on tuberculosis, that common ordinary leaf can heal tuberculosis. And that also helped my PhD students when she wanted to do a research of PhD. I said, if leaves can heal tuberculosis, then you can heal cancer. Those are major diseases dominant in the country. So what happened? As a direct type indica, which is our name, during COVID, this was handling COVID anyhow. No drugs, just put down the leaves, boil it. We did it in my home. Okay, we are locked down, but we are taking neem, agbo, and then we didn't hear anything about COVID. They have the potency. And this neem has been used to treat anti-malaria. The same thing. It is high time that we'll take this also beyond the laboratory. Let's have a product. I moved to thematic 6, AI in modern chemistry. Whether we like it or not, AI is taking the floor. And AI, I would say, cut across every of the field. Whether you are going to production, you are going to isolation, you are going AI cut across every. Because we need it to read the molecules. We will need it for us to be able to analyze our result. You just have the result, FTIR, or put on NMR. There are apps that we can use to reach those results, including nanotechnology. Once you run your SRT and other stuff, there are apps that we will use, of course, to know what it contains. We have the discriminative AI that predicts a property from a known structure. We also have the generative AI that also inverts the process. So instead of predictive, we start from a desired property and then we build it up. So there is no way we can run away from AI. In fact, the field is trending now. Those of us in physical chemistry in those days, when we look at physical chemistry, I taught physical chemistry in Madrid University. When we look at all those equations, then you are writing for them. You say, it's not clear. I'll just look at, I will look at it and say, what is not clear there? If you're me. So what is not clear there? I'll start all over again. So to get to understand that, I say, it's not clear. I'll just say, don't worry, when I log up the board, it will be clear. The board will be clear. But these days, AI has come to solve it. Physical chemistry, very simple. In fact, we have professors in that area now that it makes everything very simple. I think we need to revive that and then move forward. For instance, allicin is an antibiotic that is discovered by a neutral network. Of course, neutral network will deal with big data. But now, AI also discovered an antibiotics that is embedded in it. MIT researchers trained a deep learning model on diverse molecular database. They virtually screened the drug repurposing hub for antibacterial activity. And before we know it, allicin surfaced. And this allicin, they only know it for diabetics. But now, it's an antibiotics. The compound, very active, potent activity against drug-resistant Acinetobacterial pneumoniae and Mycobacterium tuberculosis, via a mechanism distinct from existing antibiotic classes. Why? AI discovered that. So we need to also imbibe on this. I go to bioremediation, of course, definitely. Our thematic area in this. Professor Universtiy will speak so much on this. He's an environmentalist with chemistry, so we will do justice to this when he's speaking. Now, because there are certain bacteria and fungi that metabolize petroleum hydrocarbons as a carbon source, and then it now breaks them down to carbon dioxide and water. So the plastic we are thinking that is a problem to our wastewater can be broken down by introducing microbes to clean them up. We have a typical example, a case study, Bacillus bioremediation. It's an apoid oil field in Bayelsa State. This was published in 2024. And you can see the control, nothing in the control. But when you get to using the microbes, one of it, B. maculaosis, 89%, if you use it alone. The other one, atidamine, if you use it alone, 83. Now when you combine the two, what happens? 93% performance. 93% performance. So instead of not generating this waste and allowing, and the thing was done within 35 days, allowing it to waste, we do something about it, using what we have to feed on them. So when this is mentioned that, I just think I said these are bacteria. And then another idea, you will say, we use another microbial to heat them up. We screw them away. And we use our chemistry, oleochemistry. That's generation of thin film paper. And then we mix it with our paint, and then we seal it up. If there is no air inside, they won't have opportunity to grow, and then we kill it. And then the kudos can go to the chemist in the house. The people say, our chemistry, they are good. That's our real testimony. Now, move to the last one, biodegradable packaging. Polymers, I mentioned about polymers that the environment can handle. And then there is a limit to which we can go. All these ones, as they are coming, we are using it. Some people will be packing it. Yes, I brought in the waste to work structure into covenant and also into non-mark. They pack the plastics, we blend it, we bale it. We have an MOU with an industry. This is moved into a fiber country, and then a fiber industry, and then they do duvet, they do jersey from there. And then we get our fund into the university coffer. The money lands, not in my pocket, but in the university pocket. But someone now asked me, say, after retirement, what will you do? I said, I'm going to do something machine. That's a job. And then when you see people also, they gather those things, they go to a party, they gather it. What are they gathering it for? They're gathering to sell. We shouldn't be gathering to sell, we should be gathering to give a product, which is a recycling. And that's a waste to wet approach. The waste to wet approach is not see it, sell it. It's an approach of see it, break it down, and then repackage it into another product. That one fetches more money or more income than the previous. A typical example is the starch-based film formulation, in which we also have a native starch. We can mix it with glycerol, who act as a plasticizer, and then we form and mix it alongside with clay. So instead of you to have a baggage or a pack that is not degradable, you cannot have a pack that is degradable. That is even in abroad, they couldn't do the solution. What they are telling them abroad is that when you are coming, you buy your package bags to discourage people from buying package bags. So people come with their clothing bags. Not that we have to carry it back so that we can use it. But now, development is going towards a biodegradable packaging, so that at least all those things can break down with time. And we have, this is a very recent paper, which we call Clay Reinforced Cassava Starch Film for 2025. So, as I conclude, there are 8 thematics, but one argument. Watch cassava threads 3 pillars without ever repeating chemistry. Cassava peels has handled one of the 3 thematics. Its roots feed food development, biofortification. Its peels becomes a wastewater bleaching. To leach out all those unwanted materials. And its starch becomes a biodegradable packaging film. And when we look at AI is not just standing alone there. It is the enabling tool set that is inside all the 8. And when we also look at bioremediation and medicinal chemistry, they have the same principle, but in different direction. By putting in living organisms so that they can practice their own chemistry, rather than fighting the chemistry. So that's why I know that this conference is apt breaking up these thematic areas. The shared skill across all the 8 thematic is a molecule must be formed, a mineral must be somewhere, a microbe must be developed, a market must also be developed where the products will be sold. Instead of fighting and then bringing substitutes from abroad, let us also develop our national products so that it can compete with global. The chemistry agenda for the next decade. Big problem don't need more force because it's a problem indeed. Rather, let's change our strategy. Instead of us pushing or carrying it, let's put on a roller under it so that we can move forward. To all researchers, let's begin to publish towards application. Let us also learn the computational tools that is required to make our work apt and novel. Let's also look at it at a nano scale, small scale, pilot study. See the result and then we blow it up. So our industry, I know at the end of this conference I'll take communicate. Please partner with us. Partner with us and let's be truthful to ourselves. At least if you cannot, if you don't want us to disclose all the atrocities in the industry, partner with us on this pilot plant located in our university. The results we get there will help your industry. Like I said, in China, they will bring funds to the research institute and university to solve this problem. We, as a chemist, we are available to solve problems. And we believe we will be able to get there. I want to acknowledge the following. My appreciation goes to the Chancellor of Universtiy for giving me the privilege to be here and also to the privilege of being the Vice Chancellor of the University. I also appreciate the Vice Chancellor Futa, Professor Adenike Oladipo, for hosting this event. I appreciate my father, Professor Amo, Professor Apanga, Professor Mawan, Professor Oladoja. I appreciate you. The Dean, Professor Adebola, I also appreciate. I appreciate the Ondo State Chair, Professor Kolawole, and all the members of the LSC. I cannot but also appreciate the President, CSM, Professor Rufus, represented by Dr. Fabro. Please extend my greetings to the VC, my own in Bowen. Thank you. I appreciate all the professorates that are here. I don't joke with them, I call them eminent. I respect them a lot. To achieve that seat, just 2 weeks ago we had an inaugural lecture, and I jokingly said, yes, other professors that have not given inaugural lecture, you are not sitting, you are sitting down with one. Those that have given inaugural lecture and those that have not, I appreciate you. I appreciate every participant and attendees for this event, Chemical Society of Nigeria Ondo State Chapter, and everyone at this maiden event. Thank you.
Can we give a standing ovation, everyone, our distinguished guest speaker, or keynote speaker, beg your pardon? Can we celebrate him, everyone? Thank you very much. That was a very solid word. Thank you for the job well done. It was very insightful. We can have our six distinguished ladies and gentlemen. Thank you very much. I'd like to take some courtesies. I'd like to recognize in our midst the Dean School of Life Sciences, Professor Kolawole Ajanaku. Welcome, sir. I'd like to recognize as well Professor K.D. Adedayo, Physics Department, School of Physical Sciences. You're welcome, sir. We will take a goodwill message from the Ondo State Chapter, CSN. We have a representative, Professor Olajumoke. You're welcome, sir.
Good afternoon, everyone. On behalf of the Ondo State Chapter, Council of Nigeria, every representative of Dr. Mrs. Kolawole Ajanaku, they asked me to congratulate the Ondo State Chemical Society of Nigeria, Ondo State Chapter, on their maiden edition of CSN Conference that we wish you long life and prosperity and wish everyone good. I use the opportunity again to appreciate my lecturers because I'm one of the product of two departments. I'm one of the first PhD students of Professor Kolawole. I say to thank you. Thank you for making what I am today. What I do small to express appreciation. I think I appreciate my supervisor, Professor Popola, is already a PhD when I was here. My spiritual father, Professor Ahmad, Salaam Alaikum. I thank you all for this opportunity. Good afternoon. Thank you so much. Thank you.
Thank you very much. We want to move on to the presentation of awards. All right, before we move on to the awards, I want to take some comments and questions on the keynote address. So, do we have questions? Do you have questions or you want to make some comments? All right, sir. So, we'll take one. Who else? Questions, comments? All right, sir. You can come.
Good afternoon. I'm Universtiy from Ondo State University, Chemistry Department. I want to thank the keynote speaker, and he has really imparted lots now today. However, while listening to Prof's lecture, something became a concern for me, and I hope Prof is going to assist us. Yes, there has been lots of researches I'm also a researcher. Professor Amo also assessed me in next. So thank you, Prof. During the lecture, sir, I observed a gap, and that gap, because the keynote speaker is a vice chancellor, and he will be able to help us on that gap. From our research to industry, there is a gap there. I want to ask, what is the major problem between our research and the industries in Nigeria? Before I joined academics, there has been researches, and research is also ongoing. What is the major problem? Now, is it policy? And if it is policy, sir, how do we influence the policies of government? TechFund sponsors a lot of research. NRF, local, small money, big money. At the end of the day, our industrial sector still remains the same. So, sir, what is the major problem? How do we address the problem? Thank you for that.
Good. Prof, that's a good question. That what we produce in the house is not recognized in the industry. But let me just answer it in a simple way. Simple way as this. If you don't blow your whistle, nobody will listen to you. Anything you produce is not meant for the shelf. The industry will come looking for you for collaboration. I won't say it openly. Quite a number of, at least about 3 industries in which I integrated myself into, based on the product that is coming from the work. We should be looking towards having a solution locally to our problems that will fit in globally. I was in the place to just give an address or training, and then they were now saying, no, we don't like all these times higher education. We don't like this scopus. We don't like this Q&S, blah, 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 blah. How can it be ranked Universtiy? Before we can, I remember about 4 years ago, before we can now start ranking ourselves in-house, let's take a look at the yardstick. That was my response. That is used globally. Let's look at the parameters that we were dealing with. Let's bring it on board to our own local approach. Is it fitting in? Then we brought in the SDG goals are there. What are the factors within those things? And then we brought them in, and then we now begin to skim our research towards those SDG goals. I said we have 8 thematic themes, and I've only just picked a typical example for each of the thematics. I know during the parallel sessions, everybody will present their own paper that will be innovative ideas. Don't just publish and let it stay on the shelf. Professor Lawa's student when she came for masters. I just picked my 2 papers. That is on food chemistry. I said, which area do you want? I'm in ceramics, I'm in composite, I'm in nano. I said, no, what those ones are too good. Food, good. I have 2 or 3 papers. I gave it to her. Go away with it. 3 weeks after, come back. So she came back and said, sir, this paper, where is it? Where is the product? I said, that is why you are the product of that paper. Because whatever you do with it, interestingly, my PhD works on waste, building waste. And there are 2 major building waste, the spent grain and the glass waste. So the building waste, I produce bread, 60% proteinous bread from there. And I think the professor is it in Akure here, also developed the same thing. And then he's having that product too. No competition because I did not sell my own for, I only published. The glass waste I made it into tiles. It's a development of what I now want to do for my postdoc. Immediately we had that tiles, the company called me, how can we be doing this? Interlocking projects came in, collaborated with them. I'm collecting my royalty from that interlocking company. It is not the money we collect as salary. It is additional. Somebody knows you can say, my Ajanaku, you know, to my call the Ajanaku name. He has the money. But he always want to live very low. That's it. So she came up with a product. That product is what she did and defended for her masters. And that product is selling for neonates like Wi-Fi today. For masters, she also identified a problem. So don't let us just stay in our cubicle and expect those industry people, industrial people, well, when the waste-to-wealth people want to come in for glass waste, I mean for paper waste, they're not saying, listen, you know the best. How much is the money? But what about the impact? And you see, right from one set, when I was coming up as a lecturer, what I teach my students is to develop them, the ability of industrial chemistry to come out with a product. Is it soap making? Is it board making? These boards? They were able to do it when they were in school. So when they go out, it becomes very easy for them. Now they can integrate themselves. Once they go for interview, they integrate themselves straight. Particle wall size, I've done it before. What did you use? This and this and this and this and this. There is no company that will hear that and will want to take them. So don't let us wait for the industry to come to us. It is not like that in Nigeria. In abroad, it's like that. They'll come to solve their problem, but not in Nigeria. What we need in Nigeria is that don't put it on the shelf. Place it as a product. And once you are placing it as a product, defend it. Get all the necessary registration. Is it NAFDAC? Is it get everything. You may not even go the way of patenting. Because if it's a product, I can go a way of commercialization without patenting. I'll just commercialize. And once I commercialize, I'll be collecting my royalty. That's not the end of the world. Another idea will come, another commercialization. If it is just 50,000 naira that is coming in every month from 4 products, that's 200,000. And then domestic allowance in the house is 180,000 per month. You have solved that. And you also have remaining 20,000 as tithe if you are Christian. That is just the way to go. Let's take our product off the shelf. There are so many ideas that was communicated via that paper, via your brainstorming with your student. Don't let it stay there. Come out with it. Produce something. Just produce something. It may not be the best at that time, But as you are doing it again and again and again, you will remember the formulation, even when you are sleeping. So somebody now wanted to get your product and now also want to do it. Okay, I had 53% silica. Okay, you need fluoxing, sodium hydroxide and calcium hydroxide. Potassium hydroxide and sodium hydroxide can give you fluoxing. At what ratio? 1:1. You already know that 1:1 will give you the best. But right from onset, you already know that person wants to steal your product. You just say sodium hydroxide. There's only for you to have. There's only for you to have potassium hydroxide. You will try, you won't get that your product. Because that's your brand. You don't need to hide it. But you need to. So they will still come back to you, sir. Let's collaborate. Thank you.
Thank you very much, sir, for the response. We will now take the awards, as mentioned earlier. The awards are in different categories. We have first the Excellence Award, which is going to 3 eminent personalities. First, our keynote speaker, Professor Kolawole Ajanaku, who I invite you respectfully, sir. As I bring up to do the handing over, the presentation of this award, our Professor Isiaka. Thank you very much. Can we please put our hands together?
The lecturer of today, I want to believe that he has done justice to the topic. That is to say, we have the round pool in the round hole. So I want to seize the opportunity to first of all congratulate you on this. On behalf of Chemical Society, Ondo State Chapter, I'm presenting this award to you. May God Almighty put blessing in the award.
Thank you very much. Congratulations, our distinguished Vice Chancellor, University. We move on to the next, which is going to still under that category, the Excellence Award, going to Professor Nuruddin Abiola Oladoja. Is a plenary speaker. I will invite you to please come to the podium and read a short citation. Professor Eni Oladoja is the head of Hydrochemistry Research Laboratory, Department of Chemical Sciences, at Universtiy, Nigeria. He holds a PhD 2003 in Environmental Chemistry and MSc Industrial Chemistry 1994 from the University of Benin, Nigeria. A BSc Education Chemistry 1991 from the University of Lagos, Nigeria. He was a postdoctoral fellow, CAS, TWAS 2008-2009 at the Research Center for Eco-Environmental Sciences, Beijing, China. Visiting, if you want to clap, please go on. Thank you very much. Visiting researcher, USM, TWAS 2010-2011, School of Chemical Engineering, University, CERNS, Malaysia, Alexander von Humboldt Fellowship for Experienced Researchers 2013 to 2015. The Chair of Urban Water Systems Engineering, Technical University of Munich, Germany. A visiting Professor CAS PIFL 2019 to 2010, 2025 till date. RC is China. He has made significant impact in the development of appropriate technology for water and wastewater treatment He has vast knowledge and expertise in environmental interfacial chemistry, that is, absorption and coagulation, flocculation reactions, aquatic ecological engineering, and resource recovery from wastewater. His expertise has been deployed in solving different water environments and ecological challenges, for example, preparation and characterization of reactive filter material for water purification, green coagulants and flocculant substitute for water purification, nutrient recovery from wastewater, algae biomass harvesting, and eutrophication control. His publications have received over 4,800 Google Scholar citations with an age index of 40 and I-10 index of 92. His research works have been financially supported by prestigious and highly competitive national and international research grants, which include the Tertiary Education Trust Funds, Nigeria, National Research Funds, Nigeria, International Foundation of Science, Sweden, Alexander von Humboldt Foundation, Germany, the Commonwealth Travel Grants, England, United Kingdom, British Ecological Society, United Kingdom, Alliance for International Science Organization, China. I present for this award of excellence, Professor Nuruddin Abiola Oladoja, as I invite again our distinguished Professor Abo to do the presentation. Can we put our hands together?
Professor Nuruddin Oladoja, one name to say, we happen to be at the alma mater. And at the same time, it's one of those people that I respect when it comes to the issue of chemistry. On that note, I want to say, on behalf of the Chemical Society of Nigeria, Ondo State Chapter, I'm presenting to you this award, and I say congratulations to you. The Almighty God,
Congratulations to you, sir. We'll take the next award still on the Excellence Award Series. Professor Olayinde Samuel Lawal. I read an abridged citation. Professor Olajide Samuel, please step down. Professor Olajide Samuel Lawal is a professor of industrial and macromolecular chemistry in the Department of Chemistry, Faculty of Physical Sciences, Federal University, Oye-Ekiti, where he currently serves as the Director of Research and Development in the Office of the Vice Chancellor. He obtained his first degree from the Federal University of Agriculture, Abeokuta, in 1997, and later earned MSc and PhD degrees from the University of Ibadan in 1999 and 2004, respectively. He became a full professor of industrial chemistry on 1st October 2011. Professor Lawal has held several prestigious international fellowships and appointments, including postdoctoral fellow of the Alexander von Humboldt Foundation at the University of Hamburg and Freiburg, amongst others. Thank you very much. He is a recipient of numerous national and international research grants. Professor Lawal has secured funding from organizations including the International Foundation for Science, Sweden, the Federal Republic of Germany, Seedling Labs, USA, the Tertiary Education Trust Fund, Techford, and among others. Professor Lawal has facilitated international research collaborations with institutions in Germany and has strengthened multidisciplinary partnerships of climate change research. Within the university system, he has served as head of department, dean of the Faculty of Science, member of the Governing Council, several strategic committees, nationally. He has contributed extensively to curriculum development, accreditation, mentoring, postgraduate examination, academic assessment, conference presentation. Thank you very much. He is a fellow of the Institute of Chartered Chemists of Nigeria, the Chemical Society of Nigeria, the Royal Society of Chemistry, United Kingdom, and a member of the Science Association of Nigeria. Distinguished guests, ladies and gentlemen, I present for this excellent award, Professor Ajanaku. Once again, Professor Amao, please stand. Please, can we put our hands together for you?
Honestly, Professor Lawa happened to be a very close friend of mine. And we have one thing in common. Our Oga, not professorship. I think Lawa will know. It's only between us we can see. Honestly, you have been impressing me, and you have been doing fine. I want to say that God Almighty continue to guide you. Amen. To guide you to the right path. Amen. The path of those who are favored, not the path of those who have gone astray. On that note, on behalf of Chemical Society, Ondo State Chapter, I'm presenting this award to you. And may God Almighty continue to put blessing and wishing you many more of this award. Thank you.
Congratulations to you, Professor Lawal. We move on to the Science Advocacy Award. Our Vice Chancellor took ours before she left. So next will be Professor Teni Emmanuel Olukorisha, represented by Professor Akimobola. Professor Akimobola, please. Professor Olutimei. Olutimei. All right.
Is Professor Akimobola not here? If he's not here, then I can take the award.
All right, sir. So, Professor Olutimei, can we put our hands together for you? I would respectfully invite the Vice Chancellor, Landmark University, our keynote speaker, Professor Kolawole Ajanaku, to help us with this presentation. A round of applause for him, please.
On behalf of the Chemical Society of Nigeria, Ondo State Chapter, this is a great award in the class of the Vice Chancellor of FUTA, Science Advocacy Award. I have the privilege to present this to you and say congratulations. Please keep the flag flying.
Thank you very much. Congratulations to Professor Olukorisha. The next award for Science Advocacy is going to Professor Ibrahim Abdullahi Safi. Do we have his representative? Professor Ibrahim Abdullahi Safi, represented by Professor Lawal. Our Vice Chancellor, sir, our distinguished Professor Ajanaku, sir.
This is a good task given me when it comes to science advocacy. I'm giving an award to one of my assessors, Professor Akeda. Thank you, sir, for this assignment that you have been doing for us in science. I pray for more grace and more strength Thank you for being with us.
Thank you. Congratulations, Professor Sape. We move on to the Founder Service Excellence Award. Founder Service Excellence Award. First is it's a posthumous award going to be conferred on Professor Kolawole Ajanaku. His son is here. Can we put our hands together for Mr. Ajanaku as he comes? I'd like to respectfully invite to do this presentation the representative of the President of CSN, Professor Chancellor, the Deputy Vice President CSN Southwest, Dr. Esther Faboro.
On behalf of Chemical Society of Nigeria, Ondo Chapter, we present this to you for your contribution to the society. I wish that this will be used to remember him for his contribution. We appreciate you and we pray that God will continue to keep you as we remember him. Thank you.
Thank you very much. Congratulations. Next will be Professor Afamefuna Elvis Okoronko, the Chair MSc of this conference. I invite Dr. Fabro once again to help us with this presentation.
We recognize your contribution to the society, and we are still looking forward to contribute more to the society. So this is not for you to stop, it's just an encouragement and joking to you that we are going to get more of your services. We pray that this will serve as an encouragement for your services to the society. On behalf of CSN Ondo Chapter, I present this to you.
For the next category, or still on this category, I invite Professor Isiaka Adekunle respectfully. Can we put our hands together for me, please?
As we fondly call him, he's our Baba. When I was the chair of Ondo Chapter, we worked together closely, and he's such a man that I will call him at any time. He's ready to give us his advice and help us to put in our best. I regard him so highly, and I pray that God will keep you for us and keep us for you, so that we live long to take this society to higher ground. In Jesus' name. On behalf of Chemical Society of Nigeria Ondo Chapter, I present this to you as a token of our love.
Thank you very much. Congratulations to our distinguished Professor Isiaka Adekunle. Thank you so much, sir. All right, before I move on to the next category of award, I would like to recognize and bring to the high table as instructed Professor Mojisola Nkiko, Dean Sciences, Uninet. Please, we'd like you to come to the table. Professor Nkiko, we would also like the Dean SLS, Professor Kolawole Ajanaku, to kindly come to the table, and as well as the HOD Chemistry, Professor W.P. Tomori, please come to the table. Thank you very much. We move on to the Lifetime Service Award. The Lifetime Service Award going to be conferred on Professor Aladetimi Augustine Oshodi. Aladetimi, but they said Aladetimi on the page. So, apologies. Professor Aladetimi Augustine Oshodi. I invite this SLS, Professor Olajumoye, to do the presentation. Professor Aladetimi Augustine Oshodi. Okay, Professor Monsa.
Praise the Lord. I'm happy to be here. Particularly, Professor Oshodi was the Dean of School of Science, Desk of Sciences, when I was interviewed as a graduate assistant when I was coming to this university. So it's very fortunate and very dramatic that today I'm privileged to be somebody that's not presenting an award to Professor Oshodi. This is Award of Excellence presented by the Chemical Society of Nigeria, Ondo State Chapter, to Professor Aladetimi Augustine Oshodi, a Lifetime Service Award. Today, the 25th of July 2026. Congratulations, sir.
Congratulations. Thank you very much, sir. The next award, still on the Lifetime Service Award, is going to Professor Emmanuel Ilesomi Adeyeye. Professor Emmanuel Ilesomi Adeyeye. Please, sir, we still need you, sir. Can we put our hands together for Baba Ilesomi Adeyeye?
Thank you. This award, presented by the Chemical Society of Nigeria, Ondo State Chapter, to Professor Emmanuel Adesomi Adeyeye, a Lifetime Service Award, today, 28th July 2026. Congratulations, sir.
Thank you very much. Congratulations, sir. Professor Emmanuel Adeyeye. Thank you so much, sir. We move on to the Meritorious Service Award, which is posthumous. It's going to Dr. Kolawole Ajanaku. Dr. Kolawole Ajanaku. I'd like to invite Professor Oyebi Kukola for this presentation. Professor Kukola for this presentation.
Concerning this award, before it is presented to Dr. Kolawole Ajanaku, I will request that the audience stand just a moment of silence. Dr. of blessed memory.
Inna lillahi wa inna ilaihi raji'un. Ọ̀dọ̀ ẹ la ti wá, ọ̀pẹ náà la máa padà sí. That is the meaning. Thank you.
Can we please sit down? He really was very passionate for the chapter. He gave his all. His time, his money, and then everything. Just call him at any time he's there. He had a passion also for this conference. When he was still with us, he really worked. He worked tirelessly for the chapter. So we are appreciating him and we are appreciating his family, for giving him to us while he was with them, that he really worked for the progress of this chapter.
On behalf of the Chemical Society of the Ondo State Chapter, this is a privilege and honor for me, even though a very senior member of staff of chemistry when Wahab was employed to the department. We want to thank God for the part that he played. If I have not actually interacted now, because the name that was mentioned outside of Wahab, I didn't know him for that name. But I have seen the wife since we started this program, and I did not really associate her presence with the solid that he mentioned. But now that I came up, the name of Wahab is very, very fresh. I want to thank God for the part he played in chemistry. Very, very devoted, very, very unassuming, hardworking, and we are here today to remember him posthumously. And God gives and God takes away. All glory to him. While he was with us, he did his best, and I'm glad that the Chemical Society of Chemistry, Ondo State Chapter, has thought it fit to do this in his memory. And on behalf of the society, I present this award to him, which is being taken by the family, and can see the support that members of the department, starting from our Baba, is given to him. Want to appreciate him and want to thank him for actually occupying and continue to really take care of the family after his death. Thank you very much, and I pray that his memory will continue to bring blessings to the family, to the department he has served so diligently, and to humanity. Thank you very much.
Thank you very much. Distinguished ladies and gentlemen, we will move on to the presentation of prizes to winners of state chemistry competition. I invite Professor Omonala Apapa for this next presentation.
Thank you very much. On Saturday, when we had this quiz competition, Chemical Society of Nigeria chemistry quiz competition, we had 135 registered students from schools, but 102 students came for the exam on Saturday. And out of them, the first position was claimed by Adeyemi Federal University of Education Demonstration Secondary School, Ondo. The student that came for that exam and came that result, his name is Ajekodunmi Doyisola. It's called Well, it's okay. Well, let me quickly read the results, then we'll now call them individually. So he scored 88% in the exam. The second position was claimed by MSSN Islamic Model College Akure, represented by Ali Abdul Mateen. That was the student that came, 86.7%. Third position was a tie between two schools, Higher Heights High School, Akure, represented by the student Emmanuel Ma Al-Nasoko, who scored 85%. The second person that tied with him came from Model Secondary School of Baile, Olotu Rabiat, scored 85%. Do we have Model Secondary School of Baile in the house? Do we have Higher Heights High School representative in the house? Please come up. I will call on Professor Oguntimeni, Professor Ile Mobayo Oguntimeni, to come give this the trophy to the school and also will decorate the students with the medal. Where are the people working? Not before, just the medal. The medal.
Okay, from Higher Heights International High School, right? Akure. I want to congratulate you on behalf of the Chemistry Society in Nigeria, Ondo State Branch, for coming third in the competition held last week Saturday. This is just to encourage you when you get back to school and your friends and colleagues see that you are able to bring back a medal. It will serve as an encouragement for them so that when you appear next year, you strive for the first position. I want to congratulate you on behalf of this year. May you be celebrated eternally and always be. Thank you.
I'll call on Professor Ego Adetuyi to come. Before you come, sir, is MSSN Islamic Model College in the house? Not around. Actually, they went for the exam. No, there's been this joint exam for these SS2 students in Ondo State. It's a joint exam. So I was actually told, but some said that they will come by past 12, so I was expecting that they will be here already. But since they are not here, we will skip they will collect the honor later. Okay, thank you very much. Do we have the Adeyemi Federal University? Oh, great. I'll call on Professor Kojisola Ekiko, the Dean Science Element, to come present this. We are doing two presentations to the school and to the students. To the school, they are going to go home with our first position trophy cup. Then the student, Maje Kodumi Doyisola, will take the gold medal decoration. Yes. Actually, the first position and the second position will go further to represent Ondo State at the national competition, chemistry competition, which is upcoming very soon. So we hope that we'll bring home the national cup.
Thank you, sir. On behalf of the chemical society, I want to recommend you after congratulating you. You know, that was a very phenomenal performance. And the first one happening in Ondo State. I'm hoping to see you in Abuja. And for us to win the national Okoya competition.
Because I remember when I was in Ondo State was always winning that competition. So now in Ondo State, they have to win that competition. Hoping that you are going to be a great chemist. And the chemists that make their impact. There is money in chemistry. Just come out. Congratulations. The teacher, please come. And you. So this is awarded to you, not just to the students who participated. Oh, it's your win. Come to me. Yes. Not just to the students that participated, but that is the honor to the Federal University. No, that's the I used to call it ADEMI College of Education. Now it's ADEMI Federal University of Education. I think that's the second in it. Chancellor is the first. Okay, so we award this to you. And I pray that you will have more wins by the grace of God. Thank you very much. I appreciate that.
Thank you very much. We would like to take a vote of thanks because we will still take a break before the plenary. I'd like to respectfully bring up for the vote of thanks the needed past chapter chair, Professor Ajanaku.
Man proposes, God disposes. We propose today for this conference, the opening, and we are here today. We started in peace, and we are ending in peace. Therefore, I will first of all give thanks to Almighty God for making it possible for us to have a program right from the beginning to the end. Look at the weather. Look at the environment. Look at the response. What else is we need? Therefore, join me in saying thanks to Almighty God. Because it's not easy. Having said this, I want to appreciate the coming, the presence of my Vice Chancellor, Professor Ajanaku. The keynote speaker, honestly, I'm impressed, and I continue to be impressed. He has never disappointed me. When I called him, Prof, I want to give you an assignment. I think I told you the last time we met, where he is now the Vice Chancellor, we met there to assess. Later, he now posted, I think he now became the Vice Chancellor. Then I called him, congratulate him again, and said, we are going to do this assignment, and I want you to do it properly. I know that you have what it takes to do the assignment. And he is here, and he didn't disappoint me at all. I want to believe that we have gotten one or two things from what he has delivered to us. On that note, I want to say thank you, my Vice Chancellor, Professor Ajanaku. The other plenary speakers who happen to be a close associate of mine, Professor Nuruddin, like I said earlier, we are alma mater. Professor Lawal, like I mentioned to you, we have common Oga. When we say Oga, we know who we are talking to. So I want to thank you for taking your time to come down and deliver your lecture here. My deans, the two of my deans are here. The Dean, SPS, the Dean, SLS. They are here. They started with us right from the beginning and they are still with us here. I want to say thanks to you for making it a day with us. The professors that are here, I want to say thank you for making it to have a day with us. My national president, Chemical Society of Nigeria, represented by Professor Fabro, I want to say thank you and God bless you. My ogas are here. We have Professor Opola, Professor Adeyemi. I want to say thanks for making it with us today. I cannot leave the podium without giving my appreciations to the LOC under the chairmanship of Professor Kolawole. It is not easy to organize a conference. And we see what we are seeing today. Really, they have put almost all their efforts to see that we have this, and we have that. Thank you very much. Our participants who are going to deliver their papers tomorrow, I want to say you are welcome to FUTA and to thank you for making it possible for us to have this conference. Because without you submitting your abstract, there's nothing you can do. But with your submissions of abstracts and coming down to present your paper, we thank you and we say God bless you. Other members that are here, those who came in for the award, the Almighty God put blessing in the award. I thank you for coming. If you have the award, you refuse to come, definitely. It's a shame. But we have the award. We brought you and you are here. We thank you for making this with us. The Futarians, I want to say thanks so much for making it a day with us. The members of the press that are here, most especially the PRO's office, I say thank you and God bless you. I may not be able to mention everybody, so I have to hand it off with the presence of my HOD. I am directly under somebody in chemistry.
I want to thank my HOD for making it with us. And I want to say generally, congratulations to all of us and to wish us the best of the best. Thank you.
Thank you very much, sir. Thank you very much, distinguished ladies and gentlemen. We have the plenary in a bit, and that will be after a short break. The plenary will start after this break. Thank you very much.
Please, it's time for lunch. They will serve you your food there, and I believe you have your tickets. In your bag, they don't give you. Walea will take care of you. It is necessary that we take pictures, all of us, with the keynote speakers and the plenary speakers. So please, let's go to the front of the auditorium. We'll quickly take pictures and then our deal. inside the venue.
While you sit down, we know you are really endured, but we are going to serve your many while you sit there. Can we please, are we to invite our chairman, the chairman of the conference, to the high table? Our DVP man, please come. Okay. Are you, as you are seated at that back, are you comfortable? Please, I would like you to shift to the front. Please shift and occupy the empty seat so that by the time we're taking pictures or video, we are not snapping empty seats. Please, kindly oblige us that. Hello, you can hear me? Please shift to the front. I know you will want me, don't worry. Just do that.
Stand in for that must stand my order for that we for a people.
Okay. Yes. I think we can sit this way so that we'll be able to see when the talk is on. Professor Olakoye, fellow, please come in. You are not going to the stage now. Come in. Come in, let's start the plenary, please. Thank you. Mrs. Ibeto, do you want me to be calling individual's name? Let's start this second session. Okay. While we await the plenary speakers, I would like to. Do we have anyone that would like to give any good message? Anyone? Just to take about 5 minutes now before the plenary speakers speak. Any good message from? Yes, the coordinator women in chemistry, where are you? Come and deliver a good message. Yes. Yeah, just say as it comes to your heart. Celebrate that for me, please. On behalf of women in chemistry, technical society, Nigeria, and Ondo State Chapter, I want to wish the organizer of the maiden technical society of Nigeria conference good luck, and I want to appreciate my chairperson, Mama Atapa, for this. For organizing this maiden session. I want to appreciate our Baba in the house, Baba Mo, then my boss, my lecturer, Professor Okoroko, the chairman of the organizing committee. And I want to appreciate everyone here, all my lecturers, my HOD, I will see them looking beautiful, handsome. I celebrate you all the members of staff and especially our members of staff from the University of Medical Sciences, Professor Dr. Okore, I salute you. The PRO of Chemical Society of Nigeria. I want to appreciate everyone, Mrs. Beto, for this wonderful maiden session of Chemical Society of Nigeria. I want to say thank you for coming and God bless you. Have a wonderful day with us. Thank you very much.
Let me applaud again. That's very, very, very good. The plenary speakers are here now. I would love to call Professor. Okay, I'll call Professor O.S. Lawal to the podium. Okay, all right. While he's preparing to bring his speech, the plenary speech, I want to appreciate especially our chairman LOC, Professor Okoronko. Up till late night yesterday, he was still running around, making sure that the little details were put in place. Can you please help me applaud him? Thank you. To appreciate the members of the local organizing committee, especially Professor Emi Adebayo and Dr. Jabar for taking care of the technical session, making sure they review the abstracts,
Are they here? Wave. Okay, they are outside still at the registration desk. We appreciate you. Thank you very much. I also want to appreciate all the people that stood in the prayer room. They were praying, oh Lord, we want the people that are traveling from far and near to come safely, and we trust God they are going home safely. Thank you very much, Dr. Brenda Fabisula, Dr. Ngozi Mwamaka, Okore. Wave now, let them appreciate you. I also want to appreciate Professor Lagoye. He's a fellow of Chemical Society of Nigeria, and he also represented the chairperson of the State Chapter of Chemical Society of Nigeria. I want to appreciate especially our senior citizen. I was sending the e-flyers. He said, what? I cannot see the category of payment for senior citizens. I said, sir, please do everything in your mind. Whatever you want to give us, we are ready. And he sent a great sum of donation. Please let me appreciate him. And he said, Then I also want to appreciate Bill, BIL, Backing World Integrated Limited, for sponsoring. I also want to appreciate both Fruitful and taking some things over the conference. Reach them on WhatsApp. Reach them on WhatsApp. When you reach them, and then that is how it will go. Is that okay? Thank you very much. Have you found it?
Of the existing protocol, but at the same time, it will be Islam if I feel to recognize some people here. So on this note, I want to thank of the Ondo Chapter of the Chemical Society of Nigeria, the chairman of the LOC, himself, Professor Okoronko. I appreciate the presence of Professor Mo. The Department of Chemistry, FUTA, is like my second home. Professor Adebayo, Professor Adetili, Professor Popola, Professor Isami. So it really feels good to be here today to discuss about something that is very, very pertinent to us as chemists. So the topic is in the manufacturing sector, we are everywhere. Agriculture, we are everywhere. Why doing this? While trying to provide solution, we also create problem. We generate a lot of waste. We produce a lot of hazardous chemicals. So the onus now rests on us as chemists to find ways of doing things in a cleaner way. So the challenge is now thrown back to us as chemists to see what we can do to mitigate the situation. So what is green chemistry? Two things are involved: the process and the products. We must regulate the process in such a way that we save time, we save energy, and we must regulate the products in such a way that at the end of the day, we don't generate waste. So, what is the interest of green chemistry compared to waste management compared to pollution management. So what we are talking about in green chemistry is that you don't want to generate the waste in the first instance, or you want to minimize the waste that you are generating. So when you're going to the laboratory as a chemist, the innovation now is that you make sure, okay, your formulation, your process design takes care of the fact that, okay, minimal waste production. So that you don't begin to think of, okay, now I'm generating so tons of waste, how will I dispose it? Where will it go to? So that is what green chemistry is all about. And that's what we want to talk about this afternoon. Now, so we say it provides the science-based framework for preventing pollution at source. We want to maximize resource efficiency and at the same time improve safety. So what are we doing? Whatever we generate, whatever ideas we get from green chemistry, we are bringing it to industrial pathway. Chemists are at the core of industrial development. So if you think of new ideas, you should find ways of transferring this technology to industries so that it's going to reflect in the production system in the industry and eventually reflect in the national economy. Now, what we are used to in the past as chemists is to use a lot of resources from hydrocarbons. Most of them are not biodegradable, as we are aware. They are hazardous, and they generate a lot of greenhouse gases. So we must think of ways of using new resources with the mind of mitigating problems that come from these hydrocarbon-based resources. In the past, the interest used to be huge. Somebody goes into production, all that concerns him or her is huge that comes from that production, not really taking into consideration the costs, okay, on the health and the environmental impacts, and eventually climate change. Now, what are the key things that we need to have at the back of our mind when we talk about green chemistry? So we're going to look at 12 principles. One, we're going to look at waste prevention. As I mentioned earlier on, we want to use safer chemicals. We want to use renewable feedstock instead of using resources that we cannot replace. We want to think of sustainable feedstocks. We want products that we can design in such a way that after some time they get degraded and go back to the environment safely. If we're talking about atom economy, if I put so amount of reagents into production, what percentage of it gives me desired products without necessarily wasting reagents? If we're talking about safer solvents, instead of using volatile organic compounds, can we think of solvents that are safer to use? Real-time analysis. Instead of waiting until the end of the production, As production is going on, as we are experimenting, we'll be checking to see, the safety of the production, the quantity of waste that we are generating, and how to reduce it. We want to carry out less hazardous synthesis. We want to look at energy efficiency. Can I produce the same product without unnecessarily heating it, without consuming so much energy? Can I use catalysts in small quantity? Or can I think of biocatalysis? Can I think of protein reengineering in such a way that if you apply such catalysts, you are going to have good yield? And then, inherently, we want to look at safer chemistry altogether. So, these are the principles behind green chemistry. These are the principles that drive green chemistry. Now, industrial innovation. When we talk about innovation, we're talking about new ways of doing things. How can we import these technologies that we are generating from green chemistry into production? So that's why I said responsible road mapping combines green chemistry criteria with responsible research innovation dimensions to guide industrial technology development. Now, the circular economy that we're talking about concerns design for feedstock, flexibility, recyclability, benign degradation pathways that enable chemical recycling, solvent recovery, and industrial symbiosis. Now, what do I mean by atom economy? I mean how much of the stuff I put into my reaction pot actually ends up in the final desired product. The simple chemistry that comes to mind, or the simple equation that comes to mind, is to say atom economy simply means mass of the desired product over the total mass of all reactants that goes into it. So what percentage of the reactants gives the product without necessarily generating humongous amounts of waste? Now, let's look at two typical reactions to give us a clearer understanding of what I mean by atom economy. The one that is 100% atom economy, and the one that talks about lower atom economy. For instance now, the synthesis of ammonia. Simple combination of nitrogen and hydrogen gives us ammonia. No waste generated. In the production of ethanol, hydration of ethene, the glucose methanol, 100% atom economy. But let's now look at what happens in the case of production of iron. We have ferric oxide combining with carbon monoxide. Yes, it may mean that we have generated 100% yield. It may mean that we have generated 100% yield. But what about the carbon dioxide that is generated? So that's what I mean by low atom economy. So the interest of atom economy is to ensure that virtually everything that you put into the production goes into the product without generating waste, without generating byproducts that pollute the environment. Now, In specific terms, like I said earlier on, chemistry touches all aspects of manufacturing industry. In the pharmaceutical industry, how do we bring in green chemistry? We can bring it in terms of continuous flow, hydrogenation, oxidation under several conditions. Textiles, we can talk about enzymatic desizing and bleaching to reduce water and energy use. In automotive industry, we can talk about low VOC proteins, that's volatile organic compound proteins, and waterborne formulations. Also, in green chemistry, we can talk about several media reaction. So we are talking about, instead of using volatile organic compounds, if it's possible to carry out the reaction with water, you go ahead and carry it out with water, or use supercritical carbon dioxide, ionic liquids, or bio-based solvents, okay, which are less toxic and less hazardous to the environment. Now, what qualifies a solvent to be called, or that makes us say a solvent is green? One, we look at the health impact that comes from solvents. Low toxicity, low flammability, safe to use in the laboratory, safe to use in the manufacturing industries. So one of the factors to consider is the environment and health safety. Then, we look at the source. Is it from a renewable biomass or from fossil resource or resources? If it's green, then we must be talking of sourcing our solvents from renewable biomass. What is the life cycle? It must be biodegradable and it must be easily distilled. And then the process, it must have low energy requirements for its recovery. So those are the things that qualify a solvent to say, okay, it's green, and then we can use it extensively in production. Now, what are the typical examples of bio-based or naturally derived solvents that we're talking about? Solvents like ethyl lactates. Now, where am I going? I'm saying instead of using toxic solvents, the ones that we are quite used to in the laboratory, we just continue using acetone. We just continue using dichloromethane. We just continue using hexane. Without considering the health impact of all this. So, in green chemistry, the message is that we can use less hazardous solvent and still achieve the same desired results. Example, ethyl lactate. Derived from constant or biomass fermentation. This is biodegradable, non-toxic, and widely used to replace hazardous solvents. Limon, or G-limonene, is extracted from citrus peels and serves as an excellent natural degasser and to replace ash hydrocarbon solvents in clean products. So, if you are working using these solvents, you are creating a safer environment and at the same time ensuring your own safety as a chemist. You can use glycerol. This is a byproduct of biodiesel production. It is non-toxic, it is cheap, and functions effectively as a polar solvent for specialized synthetic reactions. We can think of supercritical fluids. So what's a supercritical fluid? We're talking about something like supercritical carbon dioxide. It is non-flammable, it is non-toxic, and it is easily accessible. So what is a supercritical fluid? It's a substance compressed and heated past its critical point where it has all the properties of both a gas and a liquid. So if you use supercritical fluid instead of using hazardous volatile organic compound, then you are creating a stable environment for reaction to take place. You can use ionic liquids instead of using solvents that are not safe. Okay, what are ionic liquids? They are liquid salts. Liquid salts. Ionic liquids consist entirely of ions, but remain liquid at or near room temperature. Examples. These are different types of ionic liquids that we can use instead of fossil salt solvents. I was carrying out a synthesis in Germany, okay, and I needed to check the effects of solvents on the synthesis of some derived derivatives. And I discovered that instead of carrying out the reaction using hazardous solvents, I was able to carry out the reaction in ordinary water. The only thing I needed to do at the end of it was to carry out dialysis. And I was able to get the desired degree of substitution. So these are the various types of ionic liquids that we can use in synthesis as chemists in the laboratory that are not toxic. You can use deep eutectic solvents, DES. They are formed by mixing low-risk or prostate acid and base, such as choline, chloride, and urea. And when they are mixed at a specific ratio, their combined freezing point drops dramatically below that of other components, and they are cheaper to prepare. They are highly biodegradable and used in green electroplating and metal processing as an advantage over the hazardous organic solvents. Now, when we talk in terms of energy efficiency and processing catalysis, we can use advanced catalysts. Having good chemistry at the back of our mind, that is structured materials, okay, and 3D printed support to improve mass and heat transfer. We can think about enzyme catalysts for biomass conversion and polymerization. So these are innovative ideas that we can employ in the laboratory in terms of catalysis, reducing the quantity of materials that we put in as catalyst, and then coming out with efficient products that are less hazardous to the environment. Now, we talk about plastics everywhere for packaging, producing chairs, producing containers, different forms. In green chemistry, the interest is to look at how we can derive macromolecules, or how we can make use of macromolecules sourced from renewable resources as replacement for fossil-based materials. And this cuts across various industries. You can think about molecules, macromolecules, biopolymers, like starch, like cellulose, polylactic acid, polyhydroxyalkanoates, protein biopolymers, or composite biopolymers. And they have a lot of potential industrial applications in packaging, films, foams, adhesives, pharmaceutical binders, etc. Now, specific examples of starch-based polymers sourced from cassava, yam, cocoyam, which can be used in preparation of compostable films, foams, binders, etc. Cellulose derivatives. Cellulose obtained from wood, from cotton, from shells of agricultural waste. From there we can produce fibers for packaging, paper coating, and also in pharmaceutical applications. Polylactic acid that we can easily obtain from corn or other agricultural materials. We can use it in making compostable packaging and in controlled release matrices for drugs. Potato biopolymers obtained from legumes and dairy can be used to produce edible coatings, films, and natural emulsifiers. You can have a composite of these also to produce packaging trays and building materials. So the interest now is that we are sourcing the materials from renewable resources. They are biocompatible, they are biodegradable, they are cheap, and also by making use of them, we are contributing to environmental safety. Because when we talk in terms of biodegradation, there are products that you produce, and after some time, they go back to the environment safely. Now, from a practical standpoint, in 2010, while working as a visiting professor in the Japanese University, I was able to prepare fiber from natural resources. I was able to prepare gelatin fiber from collagen. And when we look at this fiber, as you can see, I was able to increase its mechanical property, not by further adding chemicals to it, by simply stretching. With that, the crystallinity increased remarkably. You can see the alignment following stretching. And when the crystallinity of the polymer increases, we increase the tenacity, we increase the strength of the polymer. This was further confirmed in the differential scalar calorimetry thermograms of gelatin fibers. The unstretched ones, that is sample 1 and sample 2, compared to the stretched one, that is sample 3 and sample 4. With this increase in crystallinity, I was able to increase or improve the application of the gelatin fiber. So what it means is that for technical applications, you can be thinking of making use of fibers produced from materials that are biodegradable and biocompatible. This polymer has wide applications in biomedical uses, in controlled drug release, etc. The strength was also further confirmed with the loss and storage modulus, with the stretched fiber that was modified by simple physical modification, not using solvent again. Simple physical modification, the storage modulus increased remarkably. Now, while working in Germany and also eventually transferred to another laboratory where I worked in Japan, Lawal et al. Also 2010, I was able to produce a microporous hydrogel made from cellulose fiber cross-linked with a polyfunctional glass diameter, okay, for the delivery of bioactive substances. Where am I going? How did I produce the carboxymethyl cellulose from simple agricultural waste? And what it means is that this is a replacement for synthetic hydrogels. This is biocompatible, this is biodegradable, and it is cheap. Now, these are the various chemical sources of cross-linkers used for the preparation of the hydrogel. And when you look at it, the swelling was so enormous that it could be used for the release of bioactive compounds. It can be used for application in agriculture. It is possible to load this hydrogel with fertilizers for controlled release. This hydrogel is not a foam. I just put it in water, I bring it out, and then everything drains off. It can be programmed in such a way that the release will be done gradually. So, this is a very valid example of what we call green chemistry. Because the hydrogel is one, sourced from a renewable material, two, itself is biodegradable and is not hazardous to the environment. A similar development, while working in Germany, specifically, I was able to produce starch acetate, regioselectively controlled at position 2. And with that selectivity, the starch acetate, was able to give me a stable product. And it was applied specifically to ultrasound. This ultrasound that women do, pregnant women, as a replacement for synthetic polymer. And it was patented in Germany. So what are we talking about? As chemists, we should be thinking of ways of doing things in such a way that what we'll be doing will be green. Not creating more problems into the environment. If you mop up agricultural waste, you produce cellulose from it, you modify it, it has diverse applications. It is better than using polypropylene. If I can have a product that is as strong as polyethylene terephthalate, why not? If I can modify polylactic acid, if I can do a composite with polylactic acid, or I use a polyhydroxy alkanate, and have a product that I can use for packaging with that strength, then it makes a lot of sense. So that is what I understand as green chemistry. So you can see the aperture, okay? Increasing with what? With increasing intensity of the cross-linking. The one I mentioned earlier on, the ultrasound material, simply use dicarboxylic acid and polycarboxylic acid as the cross-linker. And the strength of the material increased, and excellent, very stable, particularly because the reaction was due to selective control at a stable proportion. So here, this was published in College and Polymer Science, one of the oldest journals of polymer chemistry. Okay, and it was practiced, like I said, for drug release, for release of fertilizers and things like that as a biodegradable hydrogel. Now, other efforts from my group: oxidation, acetylation, sulfonylation, hydroxypropylation were used to produce products with diverse applications. We were able to isolate protein from African locust bean, barbaric nuts, coconut bean proteins, etc., that were used as emulsifiers for foams and gels in both pharmaceutical application and food application. Also, for packaging, adhesives, edible films, controlled release. Okay, these are some of things that we can use biodegradable polymers for to corroborate the strength of green chemistry that we are talking about. Now, biosurfactants demonstrate how microbiology, green chemistry, okay, and industrial applications can relate. Instead of using synthetic surfactants that eventually end up increasing pollution, you can use biosurfactants. You can use plant-based biosolvents, which can serve as replacement for synthetic resins, water treatment, and industrial effluent management. So what are the applications? Detergents, cosmetics, oil recovery, and environmental remediation. These are different types of biosurfactants that can be employed. You can use granulolipids, and they give us the same results with the synthetic surfactants. They are harmless to the environment. The problem with chemists is that traditionally, or industrialists, traditionally, we are used to a process, and then when we talk about innovation, particularly in this part of the world, we are resistant to it. We are rash. All it takes is what little efforts to explore new areas of making things. So this is an example of a green biosurfactant that can be used. Same thing, sulfonolipids. It's another example of biosurfactants that can be used with diverse applications. Now, industrial chemistry and national development. We look at closed loop systems. Now, what comes to our mind Then we'll be talking about chemical recycling. Solvent recovery without necessarily consuming too much energy in the process of solvent recovery. Industrial symbiosis. And like I mentioned earlier on, product design, making use of surfactants, solvents, plastics, textile chemicals, the design for the use, recycling, and safe bio-degradation. Now we talk about carbon accountability. The carbon dioxide that is being generated, instead of allowing it to contribute to global warming, it can be recaptured and turned into everyday use for preparation of foams, industrial plastics, and synthetic aviation fuels. So, what are the opportunities for Nigeria and Africa? We have a lot of biopolymers that are underutilized. We can produce a lot of biopolymers. We can produce starch, we can produce cellulose, we can produce guar gum, we can produce gum arabic from diverse biomass resources that we have. We can think of converting this into products that are beneficial to the environment. Now, another aspect of the application is in the agro-industrial clusters for treatment of wastewater, for wastewater purification, bioabsorption, and resource recovery. So, in this sense, we can begin to think of industry-university partnerships. Based on my experience, that is one area that is lacking in Nigeria. Industries don't come to us, and also we don't go to them. So most of our discoveries end up in our publications. Very good journal in Elsevier, that is the end. Someone that has used starch, let's say starch, from cocoyam, like the one that I mentioned earlier on, it's protected in Germany. And then I had little experience then. Somebody approached me, this product has very good results. Can you think of bringing it to Germany? I said, no, I'm not interested. I just try to meet them with this. What's the name of this organization? Prof knows the place very well. Baba? Okay. Raw material research. Okay. So I just link them with somebody in raw material research. I'm not interested. But now I won't try that again because I'm more experienced now. So, we need collaboration. University donors, researchers in university, researchers in research institutes, okay? We need to call a triple helix approach to solving this problem. We work hand in hand with them. We invite those who can draw out policies to make sure that whatever comes out of it is put into practice. It is then that we can begin to say we'll be able to achieve the desired impact in industrial innovation. What do we need to do? We can organize workshops, we can organize trainings where we project these new discoveries. I was working in a laboratory, and all it's needed for somebody to order an equipment, a very expensive equipment, was to call the partner company that sponsored the master student to our laboratory. A partner company that sponsored the master student to our laboratory. Then, I'm talking of 2007 now. If somebody could, in 2007, if somebody could just call a technical, it was a technologist. And what happened, we had to take a sample for measurement from our laboratory to another laboratory in another town. And each time we needed to do that, the temperature was rising. And the technology simply called the partner company. We need this, something around 50 million. It was a lot of money to be there, even now. Now, where am I going? We need partnership with industries in Nigeria. We need to establish that type of relationship whereby we'll be working in the laboratory, the sponsor part of this, reach agreements, publish this, don't publish this, let us use it for some time. With that, we have enough resources to work with and be more productive. I mentioned this earlier on. Now, challenges to industrial implementation. What are the challenges to industrial implementation? Inconsistent bio-based feedstock quality. And that is when adequate arrangement is not made for the bio-based material to be used. So it brings about inconsistency. And what am I saying? Somebody is producing starch in Igboara. Another person is producing starch in maybe somewhere around Ondo or elsewhere. So if there's no consistency in the characterization of the material, it affects the use and application of the raw material. Economic barriers, capital costs. The plants that has been designed to use fossil-based materials will be reluctant to start using biodegradable materials. Knowledge barriers. Like I said earlier on, the gap between academia and industries because of limited interaction. They are unable to transfer the technology effectively to them, and they are also not coming to us, so that gap is creating knowledge barrier. And then institutional barriers, regulations here and there. Fine, they are meant to standardize, but sometimes they work against innovation. Financing and support. I once worked in a country, outside the country as a professor, and if you are going into production, small scale production. You get loan with 0 interest. Can we have that in Nigeria? I don't think it is possible. So, unless we have in place government policy that will stimulate interest in development of innovative ideas, and when you have such innovative ideas, how to bring them into implementation, you need a lot of finance, and unless government is ready to support such innovations, it becomes a serious problem. So these are some of the barriers or challenges that we face, that are working against the industrial implementation of our green approach to production. So, Professor Ajanaku spoke extensively about AI-assisted design. So we are looking at future directions and then research frontiers. So these are the following emerging opportunities where macromolecular and industrial chemistry can shape green and transform features. AI design, making use of artificial intelligence, whether you like it or not. Initially, I was resistant to application of artificial intelligence, but I discovered that whether we like it or not, that is where we are going. And the earlier, you got into it, the better. I mentioned advanced catalysis, balance conversion, programmable polymers, bio-based polymers with tunable degradation and recycling. What does it mean? Polymers that are loaded with drugs. It will be possible for a diabetic person to have polymers implanted with insulin, specifically tailored to release at specific duration. So we can think of such tunable polymers like the gelatin that we produce, the gelatin powder that we produce, biocompatible, biodegradable. It can be loaded with drugs, and the life cycle can be controlled, to end at a specific time. Solvent link processing, low energy, polymer modification, integrated value chains, African agricultural biodiversity transformed into high valuable chemicals and materials. Then, another area that we need to look at as a future direction is interdisciplinary collaboration. We are chemists. We need to work with engineers. We need to work with environmental scientists, economics, so that we can interpret our ideas. We can't be talking about problem and then solution to problem when you only look at it from the angle of the chemist. In reality, it may be elusive. So let there be collaboration. Let's open our doors for collaboration. The TED Fund will always emphasize on collaboration. If you look at your proposal and you don't see the reasonable extent of collaboration, particularly the National Research Fund, the reasonable extent of collaboration there, it may be difficult for such proposal to say so. Because the NRF is about solving problems. And we need to look at it, we need to begin to look at it from this perspective. The way we train our PhDs, our postdocs, now let us start thinking outside the box of chemistry. What can we do with environmental management specialists? What can we do with toxicologists? What can we do with biochemists? What can we do with agriculturists? It is when we have this holistic approach to solving problems, I can then begin to think of, creating real solutions to diverse issues that result from non-application of green chemistry. But when you approach it from that end, from the end of collaboration, multidisciplinary, interdisciplinary approach to research, we are most likely going to get desired results. Notice also of bringing medical doctors into our team. The Dean of Faculty of Social Science was asking me, how do we come in to that? He said, I said, you are always welcome. When we write our proposals, they always look at what the statistics there. The design, okay, they want to see whether the coverage and things like that. So a statistician can come in easily. So knowledge is not limited to chemistry alone if you want to find real solutions to diverse societal problems resulting from non-implementation of green chemistry. So, conclusively, green chemistry is a divine framework for sustainable industrial chemistry. Industrial innovation turns green chemistry into cleaner process, safer products, and new markets. Molecular chemistry is central to bio-based polymers, surfactants, and functional materials. Nigeria as a country, we can make use of our local biomass, scientific capacity, and policy interest to build green circular value chains. And then, like I said, we continue to emphasize on collaboration, capacity building, industry, policy, and business. So these are some of the selected references. Thank you very much for your attention.
I want to sincerely appreciate Professor Samuel Lawa, who happened to be my external examiner when I was defending my PhD. He has not changed. God bless you, sir. I believe we have one question to ask. Maybe we should allow the second person to question and answer. Okay. So please, if you have any question, let me quickly invite the chairman of this session, Professor Ayesomi. Sir, please. You are the chairman of this session. Then please let me quickly announce the second, after the question and answer, the second session will be headed by Professor Ogutimeni, and the rapporteur will be Dr. J.M. Jabba. So let us prepare for that. So thank you very much, sir.
Yeah, thank you very much. Another round of applause to our head professor for the beautiful lecture, which is on the green chemistry and industrial innovation. He has told us about what green chemistry is all about, the processes, and of course the products. He has also mentioned about the challenges being faced, and of course we all know why we are embracing green chemistry. Because production from fossil fuels has generated a lot of problems, as far as environmental issues are concerned, and that is why we are going green. So he has also told us about the challenges facing the concept adopting green chemistry. and the solutions. And I believe that everyone enjoyed the lecture. Another round of applause to our professor. So because of our time, we don't want to waste too much time, because we still have another lecture to be delivered by another professor. So we will entertain just 2 questions. 2 questions. Okay. So, come and ask a question.
Yeah. Sir, I sincerely appreciate you for your presentation. I was just following you with all my heart while you were presenting. But I have this particular question. I have a PhD student, and I'm trying to. I discovered that at the age of 50, you see women, they have their body getting wrinkled. And we're looking for able to solve that problem. Wrinkle, the skin, wrinkling at the age of 50, 60 for women. So I now decided that we should formulate a functional drink and functional organic skincare products. So while we were trying to do it in the laboratory, I saw that the layer segregated, that you have the active layer separated and the white is separated. What can I do? So I saw you talking about Inspire, that we can produce extract from starch. And I don't know anything you can suggest for to produce the Inspire to find that active ingredient we carry out together in the case of skincare products. Thank you very much.
Thank you, the second person.
Thank you, Prof, for the presentation. My name is Dr. Universtiy. Yes, I'm into inorganic material chemistry and presently synthesizing metal organic framework for different applications. And there was a time I tried to go into ionotropic synthesis, trying to see how I can use deep synthetic solvents to generate my compound being a good ionic liquid. But I discovered that I'm actually running into trouble in terms of the financial costs. I've been researching to see is there any simple manner from materials in the environment where I can easily develop all these components to have this ionic liquids so that I can easily use it for the purpose. That is my question.
Thank you. Prof, can you please help us address those questions?
It is interesting that the questions are research. What we need to go into research itself to address this problem. They are not questions that I have a direct response to. So what we can do is that maybe you give me time to help you, check, and then I get back to you. But I don't have direct response or direct answers because there are research work that you are carrying out. You need to check, what is stopping what. You talk about emulsification. Of course, you only have the basic understanding for emulsification. You have the polar and you have the non-polar ends. So I need to know what exactly the problem is to see if you can produce new derivatives. I hope you are with me, madam. Okay? So I need deeper understanding of what is really happening. It may be difficult for me to now say, okay, go and use a particular solvent. What if it doesn't work? So unless we sit down and we discuss, okay, this is what is happening, then I can think of, okay, instead of using this, then you can use another modification to produce another product. So it's research based. It's not something I can, unless I do check. The same thing with his own questions.
Thank you, Professor.
All right.
I will chat.
Okay, thank you very much.
So thank you, Prof. Before you go, finally, yes, in as much as we are embracing this issue of green chemistry, we discovered that some of these the raw materials we are going to use may compete with food security, availability. How do we address that?
Yeah, thank you very much for that question. That has always been the issue. But it's not a problem. It's not a problem in the sense that, don't you think we have more than enough capacity to produce, to meet the two needs? Stepping outside Africa now, on the way to maybe or somewhere. You see bush, left, right, okay, everywhere. Is it like that in advanced countries? No. In Japan, left and right farmlands, cultivated. So, if you say, instead of eating our corn raw, why are we producing start from it? Have we maximized our resources to produce corn? We have not. So, if the demand is high, what it means is that more money in the pockets of farmers, and then they will be able to produce more. It is not enough to just say, oh, because we are eating corn, so we don't want to produce leather. We have the capacity, to meet both demands. Now, in the USA now, USA produces a lot of corn. And yes, they still produce PLA from it, that's polylactic acid, as a biodegradable polymer. They can work towards that direction as well, whereby we produce both for direct consumption and then we also produce for industrial application.
Session, but before then, let me please invite the chairman of the occasion, Professor Ogutimeni. Please come to the table. And Mr. Professor and Dr. J.M. Chaba, the rapporteur. Please come. Aye. One. Please. And sir, I think you will invite the speaker to come.
Good afternoon, everyone. We are in the second plenary session titled Environmental Management and chemistry. Is it green chemistry or innovation? I think it's green technology. So let me invite to the podium Professor Olajode. I think it's Abiola. Thank you very much.
Thank you, sir. Good afternoon. Our fathers in the house that laid the foundation, that inspire people like us to want to build our senior colleagues and my other distinguished colleagues, ladies and gentlemen. It is my pleasure to be here this afternoon to make this presentation. It's really very exciting to be here. This is a dream of more than 10 years, maybe about 15 years, to have this, to happen today. But thank God, we are all, witnesses to the occurrence. Environmental management and green technology. If you look at the screen, there's a question there for all of us. I was asked this question in 2009 by my research host when I went for postdoc. He asked me, he said, are you a chemist or an environmental chemist? What necessitated this question? Although the way we practice environmental chemistry, especially in Nigeria and developing world, is an uncommon affair. Everybody claims to be an environmental chemist. But at the end of this lecture, I'm sure you'll be able to ask yourself, you will know whether you're truly an environmental chemist or you are a chemist or you are just, either dabbling or profiteering, into the field. He asked me, are you a chemist or an environmental chemist? What necessitated this question? I applied for the CAS towards postdoc fellowship. When I approached him, he sent me, we started our discussion, he sent me 3 parts, publications, published in environmental pollution, part 1, 2, and 3. In the study, please, next slide. In the study, this is the theme of the paper, the 3-part paper. Removal of harmful cyanobacterial blooms in ground using local soil. They already developed a method, in the 3-part papers. They patented it, although it's now being applied. It was patented then. They were trying to develop a method, a flocculation method, to remove that bacteria. When there's excessive nutrient discharge in the water body, we all know there's a phenomenon called eutrophication which occurs, which leads to unfettered proliferation of aquatic flora, which could be microalgae, microphytes, another form of aquatic flora. So this is before the application of the flocculant. This is after. Because it's different. This is greenish. This is clear. So it's only the 3-part paper. So what they did, they composite of chitosan with a clay mineral, sepiolite, were being used as a flocculant, to flocculate the microalgae and get it sedimented. But they said they patented it, but the Chinese government was not comfortable with the arrangement. The fact that, for you to solubilize chitosan, you need to dissolve in acid. Or they were using acetic acid or diluted HCl. So the government thought that introducing acid into water is not ecological, it's not eco-friendly. So they were not comfortable with the formulation. And they were also using sepiolite, which is a clay mineral. They felt that sepiolite is not part of the town lake, that it is alien to the sediment, to the lake. So they were not comfortable with it. So he now told me that my assignment is this, for me to be offered a postdoc, for him to agree to offer me, to host me. He said I should develop a method, another method, looking for a natural polymer that I can incorporate on sand. Because sand is part of the sediment that I can incorporate on sand. If I can develop a proposal in that line, based on the mechanism of the reaction, which they are used to bridging, mechanism, which is one of the mechanisms of coagulation flocculation, for those of us that are conversant with it. So I developed a proposal. I chose cassava starch as my natural polymer, based on cellulose. I chose cassava starch as my business. Then the challenge was how to incorporate it. I have a good knowledge of polymer chemistry, so I proposed grafting via radical polymerization and so on and so forth. As a chemist, you always come up with a reaction. I applied for the fellowship. I was offered. Fortunately, I was offered the fellowship, so I went to China. I got there. I resumed, we talk. Just, when you are writing proposal, it's always very interesting. You have read a lot of things. You fantasize, and the reality, we don't know when you get to the lab. I got to the lab. I got there. Other for everything, they got everything for me. So I started doing my crafting and everything. Then I suddenly realized that silica, the sand that was using, sand is quartz, silica. And it's stable, it's not reactive. How do you do it? I needed to derivatize the surface. That's an ionization. And I needed some organic silane to incorporate on this thing. And I was younger and a bit. That was my first time outside the country. And I was really very ambitious. I wanted to impress him and really do a lot of work. I thought I could, make a lot of breakthrough. So I was doing all those things in the lab. Then I needed to give him a report, to me. So we had a meeting. And I was telling him this thing. He was excited with my idea and this thing. When I got to the issue of, and I told him that there's no way I can graft a polymer on sand, because sand is not active, it's not. That I needed to derivatize something, I'll need some silane, this thing. And I told him my plans and this thing. He kept quiet and he looked at me. He said, Viola, are you a chemist or an environmental chemist? I was shocked. I said, I'm an environmental chemist. He said, you're not thinking like an environmental chemist. You're only thinking about possibility of reaction, what you wanted to do. You're not bothered about the implication of what, you are planning. He said we are talking of a natural environment, a lake. It's different from your laboratory system where you create, where you simulate, a system and you apply this. He said it cannot work. Number one, all these organics that you want to introduce, it's going to create more problems. You see the difference between me and him. He was looking at sustainability. He was looking at the implication of what I wanted to do. I was only interested as a chemist. I was only interested in the reaction. You see the difference? So the difference when they're talking about, he was talking, in terms of green technology, in terms of sustainability. I was just thinking as a chemist. My PhD, I worked on green chemistry, but I didn't know I was working on green chemistry. I didn't even appreciate it when my supervisor gave me the topic, but out of respect for him, I listened. It was later towards the end of some things happened that I started to appreciate what did I do? I used clay, 45 with gravel pebbles, to prepare a column reactor to treat some water, which is a decentralized type of wastewater purification. But I didn't know. So it was, with what he told me some other things. It also made me to realize that when you're working with real life situations, it's totally different from when you are simulating, a system in the lab. For example, when you are working in the field, you can't alter the pH. You have to work with the pH of the system. You can't alter the organic load. You have to work with the organic, the load of the system. You can't alter the ionic strength of the system. So you have to consider all those, in your design. So now you see a green, chemist thinks about sustainability. That's green technology. Think about sustainability. Whereas the chemist, we're not really bothered. We're only interested in solving the problem without looking at the implication. So now let's go into the business. Our environment, our earth, that we live in. What was really the state of our environment before this thing? That is the Christian environment, which is the earth. It was a bleak, rocky globe with shallow seas and a thin band of gases. That looks like a representation of this, the earth. Then, that is at the beginning. At the beginning, the way God created the earth. It was just a bleak, rocky globe with shallow seas and a thin band. The gases then include, those liters, carbon dioxide, carbon monoxide, carbon dioxide, sulfide, and water vapor. And which means that it was purely inorganic in nature. And this inorganic, state of the earth is called the geosphere. And the geosphere is considered by, the lithosphere, the hydrosphere, and the atmosphere. With time, energy in this physical-chemical action led to the creation of life, which is, like blobs, which is the evidence of life. And they collect, more energy and start reproducing. And as they are reproducing, they created another sphere, which is, biosphere, which is called the zone of life. It is with the creation, of the biosphere, we now have the geosphere and, the biosphere, which is, the zone of life. So, with the creation of life, that is the zone of life, activities start. Life, they start to reproduce, start to defecate. The activities start, life activities, commence. And with the commencement of life activities, pollution starts. Although pollution could be naturally, occurred, and it could also be anthropogenic, that is man-made. Example of, the naturally occurring pollution involves like bushfire, like volcano, some biological activities. And we know that some, anthropogenic testing from human activities. Initially, it wasn't really a problem, pollution wasn't a problem because the world was vast and few, living, there's so minimal biological activities. But with time, with the formation of communities, population starts growing. Then it starts becoming a problem. And if you check those days, some of our cities, they are so, you perceive a lot of smell. A very good example is this. Although it has reduced now, I observed that I was in Lagos last week. If you enter Lagos, Lagos has a peculiar odor. It is because of, waste, poor management of waste. And, this also caused the onset of different types of, waterborne diseases. So, because of poor management and debris, ancient cities were often noxious places. Then, with time, at about 1000 CE, that is in the Common Era, the emergence of air pollution was caused by coal usage. Then, with industrial development, that is which around the 1770s, coal conversion, that's conversion of coal to coal for iron smelting also exacerbated air pollution. And between the Middle Ages and the early modern era, unsanitary conditions due to poor management of disease, to epidemics of deadly disease in at least was reported in Europe. Then around the 19th century, water air pollution and accumulation of solid waste characterized most of our urban areas. Like the example I gave about the issue of Lagos and some of our urban centers. Then, with human development and industrialization and population explosion, pollution became a global issue. It became, a global issue that, nations, and now governments are now interested, government of nations, became interested in the issue of pollution. Because it has not become, a global issue. It is, the issue of managing, how do we manage, it has become a global issue, and some of the, effects or the impact of pollution are now being felt. So, how do we manage the problem? That comes, to the issue of environmental management. Environmental management is a balance of economic growth with ecological preservation. We're talking about pollution resulting from human development and economic, industrialization. So, when we're talking about environmental management, you have to strike a balance between development and sustainability of the environment and preservation of the environment. And the principle of environmental management is predicated on mitigating degradation. That is, you try to prevent environmental degradation and accountability. You account for your action so as to prevent, the environmental. So this environmental management guides government, businesses, and communities on the issue of natural resources, use, and promoting sustainability. What are the core principles of environmental management? The core principle are listed: sustainability. That is development that meets, the future need. That is, when you are talking about development, you have to think of the future. You don't develop at the expense of the future generation. So your environmental management, one of the core principles of environment is sustainability. Then precautionary, you prevent environmental degradation even without conclusive scientific evidence. A very good example is the raging issue. One of the emerging contaminants is microplastics. Some of the claims about microplastics are speculative. It has not been confirmed. But despite the fact that some of them are microplastics, we are being proactive instead of being reactive. That is why you see there's been a lot of studies about monitoring microplastics and detecting. So even when you are not sure, some of the emerging contaminants, the claims about the implication of this, and some of them are speculative. really know about. So you have to, your environmental management strategy, one of the principles that to be precautionary. Polluter-based principle, that is the polluter, whoever is responsible for pollution, take responsibility for the management. That's the polluter-based principle. You bear the financial cost of prevention, control, and remediation. Prevention, you try to prevent instead of management. You don't even allow it to happen than to be thinking of devising a strategy for the management. Then integration. For any development, you try to look at, integrate environmental impact. That's when you need to do environmental impact assessment before you start any development. Then public participation and accountability. We make sure that the stakeholders are involved in environmental management. Environmental management strategy. That's specific pollution control. Some of them are listed there. Some of the specific environmental pollution strategies include revenue disposal system, such as sanitary landfills, municipal engineered landfill system. Although some of our landfills are not engineered, maybe you are just dumping something there, but start dumping there. But you see, engineered landfill system where you have to have, a liner, create this thing and dump this. That's for solid waste management. Emission control system for automobiles. Most of our cars, the exhaust have catalysts, to prevent the emission of obnoxious gases. Sedimentation tank in sewage system, sedimentation tank in wastewater or even in drinking water treatment system. Electrostatic precipitation of impurities to prevent, flaring of obnoxious gases into the atmosphere, or the practices of recycling. That's why we're talking about the issue of resource recovery or circular economy. Then, sustainable environmental management. We have talked about sustainability. It is, a development that strikes the balance between development and the impact on the, preservation of, the future environmental quality. So you strike a balance between the two. That's sustainable development. Environmental problems does not know political boundaries. So because of this, if there are environmental issues in the US, it can get to Nigeria. It will look as if leave them, it's not their problem. Environmental issues knows no political boundary. If there's a water pollution at Ikare, for example, water pollution, that is, pollutants are being discharged into flowing water, for example, that flows into the Atlantic. I'm just giving an example. It means that it can get to Togo, it can get to the Republic of Benin, it can get to Brazil, or any other country that is linked to the Atlantic Ocean. So because of this, because environmental issues are no boundary, all nations are concerned about what is happening in one country or environmental issues in any nation. I remember sometimes around 2008 and 2009, there was a public lecture in my university, and somebody presented a lecture on climate change. But the professor, and some other people tackled the person and said that, what are we talking about climate change? We are not polluting the environment. How does it affect us? We should forget about it, live our life and forget that climate change is the developing world agenda and all those kind of things. But we know. I believe the people they're talking out of ignorance. You can't, for the example I gave, a water contamination in the Caribbean can get to Togo. It does not know when you cross from Nigeria to Togo. It has no political business. So because of this, the issue of sustainability was the focus of the 1992 Earth Summit, which took place in Rio de Janeiro, that is in Brazil. That was in 1992. But do you know what? Despite how beautiful the concept of sustainability is, it's difficult, to implement because it comes with its own challenges. But with the reality that is, coming up now. It's not the issue of climate change and some other, attendant, environmental challenge. It is clearly that we can't, treat it with levity. So we know there will be more environmental treaties with time. Next slide. Like I was saying, though there has been a lot of treaties which is non-binding, there are a lot of treaties they are not binding on nations. Because, let me give a very good example is this. We know what deforestation costs. But when, you are advised to stop or minimize deforestation, you know the implication. It's going to affect the economy of a community. It will affect the economy of some people and some industries that depend, maybe some millers, the timber loggers, the people selling timbers, the communities that house, where this will be affected. So when you're talking about sustainability, I just gave that as an example. We are talking about sustainability. It causes economic and social hardship. So because of this, most nations don't want, or most nations, or most communities, or industries, and if, for example, you're looking at an industry, let's say oil drilling now, you are drilling oil and your process or your procedure, your process usually lead to oil spillage. It means that if you are going to, reduce your spillage, you either adopt a new method which will cost you money or cost either training and all those things. So because of this, sustainability, sustainable environmental management always bring achievement. So because of that, nations don't want to adopt it. So because of this, they always incorporate provisions to encourage adoption of, especially for developing countries. For example, recently, America, Trump, agree with the issue of control for climate change because of the implication on American industries. So some of the measures that usually included to encourage the adoption of sustainable environmental management, financial cooperation, technology transfer, differential implementation schedules, and obligation. But in most countries, they allow each country to define the compliance according to national interests. Sorry, next slide. Then let's look at green environmental technology. It is an emerging concept that encompasses scientific innovation designed to minimize environmental degradation, reduce greenhouse emissions, and conserve natural resources. If you look at what green environmental technology is, you see it has to do with the issue of sustainability. That means a sustainable environmental management. It utilizes a combination of environmental science, chemistry, monitoring, and all other technology or scientific knowledge for resource-sustainable continued prosperity on Earth. It's a sustainable, eco-friendly alternative. How did it come about the issue of green technology? That is the emergence. It actually started during the Great Depression of between 1929 and 1989, when the United States enacted the Soil Conservation Act of 1995 to address the Dust Bowl disaster. What happened? Around that time, before the Depression, because of an increase in the price of wheat, many farmers, went into the bush, started cultivating plain grass lands to plant, wheat. Unfortunately, the Great Depression came, and also, drought came, where no rain distant. So everywhere the land become parched, and unfortunately, the land become parched, and they are bare. They removed the vegetation. So when there's a wind blow and any form of breeze, start to raise the dust particles. That was the great the Dust Bowl disaster that occurred, I think around 1930. That was the genesis of, the enactment of the Soil Conservation Act, which signaled, the beginning of the green technology. And this was further solidified by Environmental Protection Agency (EPA) in 1920 because of the great awareness of, ecology, and the ecological implication of some of our human activities. Then the green technology gained momentum around 1990 due to the impact of coal-fired industry because of industrial development. Then many sustainable development and green technologies have been developed, and this has helped, to prevent reservoir damage, control floods, protect public health, reduce unemployment, and maintain river navigation. What are the focal points of green technology? The use of, a shift from the use of renewable, the use of renewable energy. That is, shift from fossil fuel, which is not renewable, to renewable like energy sources like wind, solar, hydroelectric power. Those are some of the focal points of electric mobility. Mitigate carbon emission. When you use fossil fuel, it generates what is known as greenhouse gases, which are the culprit on the issue of climate change. So there's a shift to the use of electric and hydrogen-powered engine. Smart agriculture, which reduces the use of herbicide, pesticide, and making application of fertilizer and some other farm implements more specific. Carbon capture, to reduce, the emission of, or to capture, these greenhouse gases from the atmosphere. Green building, sustainable agriculture that incorporates energy efficiency, appliances, recycled material, and smart heating cooling. From there, we'll be able to reduce the carbon footprint of, the domestic carbon footprint. Waste management, shifting from seeing, wastewater and waste as a body to seeing it as a resource. That is the issue of circular economy. What are the benefits of green technology? They help, when you capture the greenhouse gases, you have to protect, the environment. And the issue of climate, you have to minimize the issue of climate change. So climate change protection, resource conservation, from sustainability, we'll be able to conserve, our resources. It prevents depletion of critical natural resources. Financial savings, lower operational and energy costs, improve public health, when you manage the environment sustainably, at least it helps to improve, public health, and enhancing company reputation. Now, all of us is one of the reasons, if anybody tells you that a non-chemical green material and all those things, that is why you're buying ginger and some other products that we believe is natural, non-chemical product. It's helped to enhance company reputation. Now we have talked about, I don't want us just to talk. I just relate to us. What have we done to promote green technology? So I want to showcase some of our contributions. I am from Ondo State University. My research group is the Biochemistry Research Group in the Department of Chemical Science. The overriding goal of our research is to understand the chemical state of water, decipher the interaction and restore impaired water to the pristine state. That is to purify water. Our research focus are listed: environmental information chemistry, aquatic ecological engineering, and resource recovery from wastewater. If you look at them, they are all part of the focal point of green technology. So what has been our contribution to green technologies? Let us look at some of our contribution. Using each of those, our research, focus. Environmental and environmental chemistry. For example, the first paper in there, we used self-propagation combustion method for the synthesis of solar active nanoferrite for chromium-6 reduction in our system. Chromium-6 is one of the emissions, pollutants in water. Then, instead, using photocatalysis, instead of using UV light, we decided to use abundant renewable energy from the sun. So we prepared a solar active ferrite, a catalyst that can be activated by solar without using any other form of energy. It's renewable energy to photo-reduce chromium-6 to chromium-3, which is safer. Then, the other one, a new indigenous green option for turbidity removal from aqueous system. The common coagulant is alum, but alum has its own challenges. The issue of Alzheimer's disease and causes some neurological or whatever if you overdose, the water. So we're trying to seek for substitute to alum. We use Margarita descodia, the seed of a plant that we extracted, it is water extract. We use it for turbidity removal from to treat turbid water, like when you have your well water during rainfall, or surface water that is fetched from the stream from system. Then we also develop a reactive filter from green resource for groundwater defluoridation. One of the challenges of groundwater, or consuming groundwater, is the issue of fluoride contamination, which causes a lot of problems. Dental fluorosis. It's a very big problem in some countries, like even in the northern part of Nigeria and some countries like India. You see a lot of these things. So we develop a reactive filter from using the shell of gastropod to capture fluoride from groundwater. That's the snail that we eat. So the shell that we throw away, develop a reactive filter from it. We also develop another reactive filter from a green composite reactive material from lateritic soil, and a combination of laterite and gastropod shell. We combine it to also develop a reactive filter for groundwater defluoridation. That is for environmental intervention chemistry. For aquatic technological engineering, I told you of a problem that they gave me to solve when I went for postdoc. So that is the article published for me. Modify local soil and sand with extract from Moringa olivera. Moringa olivera is a natural coagulant. We combine it for effective removal of cyanobacteria bloom. Then we mitigating the extreme flux of sedimentous phosphorus in invasive water hyacinth bloom system using a boundary waste material. Water hyacinth, the problem it causes, affect navigation, deplete oxygen, and some other things. It's a big problem in Lagos and some other coastal communities. And we found out that what is feeding it, what allows it to proliferate your fertile production is because of sedimented nutrients. And phosphorus is the limiting nutrient. And it's been found out that if you can, there's a process they call sediment capping. That is, if you can trap the phosphorus, you don't allow it to be released, it's not going to furnish the overlying water with phosphorus. That means you're going to starve the overlying water with phosphorus. So we did it, we prepared, from gastropod shell, because of the rich calcium, we used it to trap the phosphorus in the system to prevent the proliferation of water hyacinth. Then occurrence and seasonal distribution and probabilistic source specific health risk assessment of dissolved trace metal in southwestern river Nigeria. If there are issues with a polluted water, you need to first identify the problem so that you know how to approach it. So that's what we did here. In another study here, we tried to monitor nuclear aeronautic, recycling aeronautic and carbon is selected river in southwestern Nigeria. Those are contributions to aquatic ecological engineering. The resource recovery, which is comes in terms of the circular economy, which is one of the focal points of green technology. We use the green reactive material for phosphorus capture and remediation of aquatic wastewater. Aquaculture wastewater. Aquaculture wastewater, if you notice, wherever they are rearing fish, these are catfish, where they discharge the wastewater, you see how rich the vegetation will be in that area. It's because of the rich nutrients of the wastewater from the feed and from the waste from the district. It has been confirmed that the aquaculture wastewater is very rich in nutrients. So one of the nutrients is phosphorus. So we develop a reactive material to capture the nutrient from the water. It can be used as a fertilizer, but managing a large volume of water can be very challenging. So instead of, and keeping large volume of, instead what we did was to develop a method to capture the phosphorus from it. We capture it in a solid form. Then you can now apply it. Although we applied it in another study, I don't know whether I reported it here. We applied it in another study where we look at the fertilizer value of the phosphorus capture. So here, preparation and characterization of a decentralized modular reactor for nutrient recovery from yellow water. What is yellow water? Urine. Your urine is very rich in nutrients too. So we develop a modular reactor to capture phosphorus, to capture nutrients, that's phosphorus and nitrogen, that's nitrate and phosphate, to capture it from your what do you call it? Yellow water, that is urine. We didn't use urine because it may sound offensive. So we put it as yellow. It is usually called yellow water. That's this thing. So here, background with frontal properties for harvesting. Microalgae, I told you in the study, for example, cyanobacteria, which is poisonous. We tried to sediment it by adding a flocculant to sediment it and make the water clean for use. But now things, research has moved from just sedimenting it, except for the non-poisonous microalgae. We harvest the biomass because the biomass is useful. We found that some of them are used as nutraceuticals. Some of them contain a lot of resources that can benefit human beings. They use, microalgae as feeds. So because of that, and because of the nature of microalgae, it's very difficult for you to capture them from this thing. They are very small. And because of, the cell wall, they are like colored in water. They will not flocculate. So we needed to develop a method to capture them too. And capturing them, harvesting them, found out in microalgae industries, harvesting industry. The mode of harvesting contributes between 15 and 25% to the overall cost of process. So if you don't get it well at that stage, you are going to fail. And then also, when you are harvesting, you have to be conscious of the issue of contaminant. And for some microalgae, when they are stressed, when they are disturbed, they secrete cyanotoxins, which are very, very poisonous. So you have to be conscious of it. So you need to develop, a working harvesting, an effective, harvesting procedure. So we develop, use a local green coagulant with fertile properties. Instead of the normal coagulation flocculation that sinks, no, it floated. And we harvested from the top. Because of the fertile properties of the coagulant. Then, this is another, microalgae harvesting biomass. We got this coagulant, we developed this coagulant from the shell of gastropod. That's where we developed the coagulant we used here. don't see this here. This has changed. This is a part of resource recovery. Here, tapping into the balanced potential of sparingly soluble salt for enhanced flock physiognomy. This is more science, process enhancement in trying to harvest microalgae. If the flock is not dense enough, it will affect the process economy. So we exploited the sparing leaf because magnesium salts are sparingly soluble. We exploited the ballast potential to improve the process of the microalgae harvesting. Here, we look at the effect of different coagulants on the overall quality of harvested biomass. So we use different coagulants and we evaluated the nutrient profile and some other properties of the harvested biomass. No, I'm not finished. Or you want me? You are tired of me. Here, we are trying to create a zero waste discharge aquaculture waste water. Like I mentioned, aquaculture waste water is very rich in nutrients. And when you are talking about wastewater, you have the liquid and you have the semi-solid, which is sludge. And discharging managing the wastewater is a problem. So we developed a system where you run aquaculture system, your tank fish system, where you discharge nothing. That's a zero waste discharge. We develop a system where we manage the wastewater that you recover, you treat the wastewater to reuse and you extract the nutrients and other valuables that are there. That's zero waste discharge, wastewater discharge system. Then, like I mentioned before, the nutrient recovery, we use it to plant crop and some other things that will recover from yellow water. So, takeaways. There's a common saying among some, we say chemists recreate nature. And if we actually, and somebody mentioned it here, which is the truth, the environmental problems are caused by what? By us, chemists. And if there's going to be, a solution, we are also the one to provide, the solution. So, this responsibility is on us, whether you are an environmental chemist or you're a chemist. We should be conscious of the issue of sustainability. Thank you.
I want to appreciate Professor Oladoja for the dissertation. Are you a chemist or an environmental chemist? However, before I call on Dr. Jabba to give the repertoire, let me quickly call on the Muslim Secondary School. Please come forward for your award. They came second during the quiz competition. Where are they? Please come forward. And I would like to call on Professor Adesomi to present the award to them. Adesomi? Please come. With a score of 86.7%.
Assalamu alaikum. Yeah, I want to congratulate you for the brilliant performance in our very good quiz. And I wish you a greater height. And I pray that we shall be better than us. Amen. So congratulations.
For producing this brilliant mind. Second position. So, as first and the second position will represent Ondo State. By August, we will know where we're going to do it. So we'll get to you. You understand? So go and get it because we want you to bring the cup back, the national cup. You understand?
So, we present this to the school. So, as we have been told, go and prepare very well.
Yes.
You can make content content.
Yes.
So, congratulations.
Professor Ajanaku, we highly appreciate you for the high and educative plenary session. Without any doubt, we have all gained from your wealth of experience. Generally, a discourse on sustainable pollution control using green technology. Of course, that is the area world is looking at now. With the afraid of environmental impacts of the synthetic material. Equally, he emphasized on waste of pollution, environmental pollution, where he mentioned geosphere, which comprises of lithosphere, atmosphere, hydrosphere, and biosphere are sources of environmental pollution. In such a way that green technology is employed to resolve these environmental impacts. And using green technology, he highlighted benefits of the technology. Where he mentioned capturing of greenhouse gases. Greenhouse gases responsible for climate change, that may be responsible for several environmental issues. Equally, he mentioned resources conservation as part of the benefit of green technology in resolving environmental issues, public health protection, and economic stability. All these were highlighted as benefit of green technology in resolving environmental pollution. Prof, thank you once again for your contributions. I will have all the questions.
We are coming to the end of this plenary session gradually. Professor Ajanaku, that was superlative. Thank you very much. You know, I'm still growing. The professor, but I'm growing, you know. But I've grown to a stage when I listen to a very good lecture, I know that this is very good. So that was very sir, someone said that when you listen to a lecture like this, though I would like to listen to it again, that the only thing you can do is to put a full stop, then entertain questions. So that's what we are going to do now. That there may be people in the audience that have some questions from your lecture. So I think we should just give them a chance to ask questions. Thank you, sir. So we will entertain like 3 questions. So please just signify by raising up your hands if you have questions or even comments from our professors if you have comments. Okay. One, okay. Is there any other hand there? I think one. Just stand up as you are raising up your hand. Just move towards the podium. Okay. Another one. Okay. All right. Just one question. Yes, that's okay. So we'll take the. Just ask your question.
Thank you so much, Prof. It's very good to me. But can you use your good office to address this issue of environmental management to the road construction people? You move closer to the way you construct it. All the coal town, all that beside, and the effect of it is the effect in the people around that place. Sometimes you talk to them or see them, you see that something is happening somewhere. Whereas a long time degraded attitude. So maybe you can do a good office to address the Ministry of Works, and you should handle the waste in the right way.
Thank you so much. Thank God I have my very senior colleague here, Professor Ayesoni. He interacts more with them than me. But that's not even the issue. They know all these things. They have the different units for this. They know about EIA. I'm sure they even do for some of. You can't do any major development without looking at the impact of what you're going to do. But we know us like any other thing we do. It's not just environmental. It's a lot of issues. I still have about Obi. I don't know anybody that lives around there or that has been there in recent time. They have been constructing our road for more than a year now. It's really, the punishment we are inflicting on us, you can't even imagine it. If you see I'm not the kind of person that like riding a dirty car. But you see my car now, it's always dirty. If you, that is, I have to wind up, before my AC is not working, I'll be managing with the sweat. If you wash your car before you get to out the road, it's messed up. I was asking, I think you're supposed to take this into consideration when you are constructing a road. We know all this, it's not that we don't know. They have all the units for environmental. When you get to the ministry of some of this, you have people that are as knowledgeable as you there. But it's like our attitude to many things.
Thank you very much. Before you go, sir, while listening to your lecture, it just came to my mind. I'm sure it will cross many other people's minds with that. This is your slide. Is it shareable? Yes, sir. If it's shareable, I think we would like to have a slide after the presentation. Thank you. Okay. So thank you. And thank you. And maybe my own personal comment. I know that a lot have gone into this conference, and I want to appreciate the organizers, our chairperson. Yes, because chairperson, you have done a lot of work, which is fantastic. Being in maiden edition in Ondo State, right? And I want to thank Professor Kolawole is also here. Professor Adebayo, I know a lot have gone into this conference. I know that next year will be better than and I gave an idea that next year we are not using this, we are using it. So that we can see. Thank you very much. Thank you so much.
I want to appreciate Professor Ondo. Thank you very much. Dr. Jabbar, thank you very much. And my chairman again, I want to appreciate you. And I want to appreciate our presenter, my examiner, Professor Lawa. I celebrate you. Professor Ladoga, thank you for the lecture where you did that. Sir, please we appreciate your slide so that we can have something to take home. And I want to appreciate all my professors seated, all the members of Chemical Society, all the participants. Thank you for making today a productive day. We are grateful. Before closing, I will so call my chairperson. Before closing, please be reminded that the program tomorrow will be taking place at We'll be by 8:30 a.m. We'll be having women in chemistry breakfast meeting. Please, if you're a woman, make it a day with us. 8:30 on dot. Within 30 minutes we'll be done. At CHCLT SBS building, chemistry laboratory, very close to the School of Postgraduates. By 8:30 a.m. 8:30 a.m. Please, women. 8:30 a.m. Thank you very much. Then the technical session will start by 9 a.m. tomorrow at the SPS building. SPS. We are not using this place tomorrow. SPS building. Then the certificate will be given after the technical session tomorrow at SPS building. Thank you very much for making today a product fair. We love you and we appreciate you. We are giving you all the one of my chairman, Professor Papa. We are waiting for you, ma'am. We are waiting for you, Prof. All right, on behalf of the university, I have a call on Professor Oladoja. Nuruddin Oladoja from Ajanaku University at Kolawole. On behalf of the Vice Chancellor, I want to give you this computer. Thank you very much. Okay, I'm just taking the picture. Okay, on the same page, I want to call on Professor Lawal, all the way from Federal University, on APT. He has been with us right from yesterday. From the Vice Chancellor's office, please, we want to give you this. Thank you. We appreciate it. All right. We are done for today. I think we should. Are you calling me? Okay, the announcement, have you had an announcement so far? Tomorrow we continue with the technical session. We will have the technical session tomorrow. The technical session will take place by 10 o'clock at the SPS School of Physical Sciences. We are the women in chemistry on the Chemical Society of Nigeria, Ondo State Chapter, will be having the breakfast meeting by 8:30 at the SPS also. So please, if you are a participant, we want to see you and you are a woman. Even we are not only limited to women, please. It's open to the men also, yes. Because we shall be having a talk delivered by Dr. Ondo State Chapter. She's the director of NASENI. And you know that you want to begin to make products, from your research findings. You need to meet her, because sometimes if you need to do some engineering, construction and all that you will need for your equipment, you need them. So please make it a point of duty to be at the School of Physical Sciences by 8:30 a.m. It's a breakfast meeting, that's why we make it that early, so that we can now from there begin the technical session. Is that okay? Thank you very much. I wish you well. Okay, Dr. Bye.